I think I got everything done. I feel like I'm missing something, but whatever it is, we'll overcome it. So I'm pulling up my
Has your
notes.
employer ever said, "What the hell are you doing on this thing? No swearing, no shirt, nothing."
Shorts are optional.
Shorts are optional.
Corley Moore, Firehouse Vigilance. This is weekly scrap number 119. Making sure it's running here. It looks like it is. I'm just making sure. I don't know. Hold on, Dennis. I'm going to sit here and wait and see if this updates or if anybody says that it's working. I'm going to hit the refresh button and just see what that does to it.
You're on Facebook, huh?
Yeah, there we go. Okay, it is live. There's 43 people logging in. Oh, okay. Sorry, it was locked up on my screen, just so everybody understands. Okay, I'm going to start again just for the sake of whatever, continuity. Corley Moore, Firehouse Vigilance, weekly scrap number 119. My guest this evening is the incomparable Dennis LeGear. He is retired captain out of Oakland, California, and if I tried to list everything he was responsible for there, it would take up most of this scrap. So, he is the guru when it comes to hose spec, pump spec, hose and equipment layout, fire stream development, laying out compartment space, hose beds, etc. If you want to know about equipment, yeah, he's the guy to ask. He owns LeGear Engineering, where he is single-handedly trying to improve and engineer a better future for hydraulics and water moving. And we are going to talk about all of that. So I'm not trying to gloss over everything. I know you won't believe me when I tell you that this is the shortened version of this man's bio. He is a mainstay on Brass Tacks Hard Facts. He is on UL NIST panels. He writes, he teaches, he consults, and most importantly, he is having an impact in the fire service with what his passion is. My brother, Dennis LeGear, welcome to scrap number 119.
119. It's quite impressive, Corley. 119 of these things. So I'm happy to be here. Thanks for having me on.
I'm excited, brother. I hope you. I tried to melt down everything that you were involved in. It's. I feel like I did you a disservice. Anything I miss, anything you wanted to add, without going too far into the weeds on the intro. Go ahead.
Actually, it's been a lot of people supported me, from manufacturers, Key and Elkhart and others, I try to maintain a relationship with all of them, TFT, North American Firehouse, all the big apparatus manufacturers. I try to have somebody on the inside, and then as many fire departments and mentors as I can have, and as I cast a wide net, and I try to pick out the nuggets and then condense them and simplify them down to just the basics. I'm a basics guy. I'm a bake the cake, not on the fire ground. Get all the complicated stuff out of the way. And then the fire ground's more like you show up and all you're doing is you're cooking a steak, and it's either medium rare, or well, that's it. So 3 options on the fire ground.
I love it. And like you said, melt it down. And if you can make it, and like I always say, make it so simple that even a truckie can understand it, right?
Crucible, refined metals. Yeah, that's what we want.
All right.
So
perfect. Okay, there we are. If audience, get your questions ready. 100%. If you have questions about hydraulics, hose, nozzles, this is the man. You get the chance to ask him. So get your questions ready. If you find value in the scrap, make sure you go to firehousevigilance.com. You can click on the support button, click on the donate button. My whole goal is to never run ads during the live scrap or anything. And so if you guys support it, that will never happen. So anyway, I always like to say that. And now we kick it off and get right into it. Now, Dennis, I don't know if you know this story, but the first time I ever heard your name, I was on Facebook. It was a few years ago. And I was just getting involved with posting stuff on the internet. And we read an article. I don't know where the article came from. I couldn't pull it up if you asked me to. But someone said, hey, if you put like a 3-foot section of bigger diameter hose on the end of your hand line, it will reduce nozzle reaction. So me and my guys ran out there, and we got a 3-foot section of I think it was 3-inch at the time. Might have been 2.5. And we stuck it on the end of a smaller diameter. I don't remember again. And we took video of it, and we took some slow-mo video, and then we posted it.
Oh, my God, I remember this.
Yes.
Yeah. I commented heavily on that.
Dude, 100%. And that's the funny part of the story is the video did very well on Facebook. Like before then I had 100 views or 200 views. This one had like 90,000 views, And then I was like very proud of it and everything like that. But and
that gave me a lot of heartache.
Well, not even that. I just didn't know. I didn't know what I didn't know, to be honest. You know what I'm saying? I honestly,
Yeah.
And it was like, it's easier to handle. And maybe the weight made it easier to handle or whatever, insert. But at the time I was calling it nozzle reaction. And you came in and you wrote a novel, not a novella at least.
Yeah.
And I was like, I got on my computer. I wrote I answered back like this huge long thing. And I was like, you know what? Maybe I should see who this guy is first. And so I actually went and found out who you were, and I was like, I deleted everything I wrote and never posted it because, like, hey, okay, this guy knows a lot more about hose than I ever will. So anyway, that was my first interaction with meeting your name on the social media sphere for what it's worth. Go ahead.
Well, probably the audience is kind of interested about that at least. Paul Shapiro, who I consider a friend, prolific author in the fire service, fairly controversial, more into the big water and supply side stuff. Big fan of automatic nozzles on hand lines. And some of that position may have changed over the years. We're all entitled to change our positions as you have a better understanding.
Sure.
And a subject. But he, a few years ago, and I'm going to say it's more than a few years ago, this could be 2 decades ago, he put a section of 2.5 on the end of an 1 3/4, enhanced 1 3/4. Let's just call it like 1.9 inch. And he's like, look, you can flow 250 gallons a minute or 300 gallons a minute. And this hose is very easy to move around the fire ground, and it's very manageable. And it's true. However, there are a lot of caveats to that. It's kind of a parlor trick. My belief is a commercial hand line should be able to be stretched commercial distances. So we're talking 200 to 500 feet. You should have a pump discharge pressure that is reasonable. So one of the problems with that setup would be if you wanted to go 250 feet or 300 feet and you're pumping at 60 pounds or 70 pounds PSI per 100 feet of hose. As soon as you're 300 feet out, you're way above 200. But the reason it works is the water is traveling at extremely high velocity through the 1 3/4. And we could do the math and figure it out, but let's say it's 30 or 40 feet, 32 feet per second. And when it comes to the enlarged area, right, it would slow down. So you have this very excited water going through the 1 3/4 at a high friction loss. It's being rammed through that 1 3/4. Then it gets into this larger chamber and it's going to slow down. So that's good. So that you have less excited water. Now that larger piece that you put at the end, let's say you took 72 inches.
Okay.
So let's say it's like 7 feet, 3 feet in front of the nozzleman, 4 to 5 feet behind. Well, that is now a slowing, what I would call a stilling chamber for velocity. You're slowed down. And then that system now has some weight to it. There's so many pounds of water per foot. And also very important is in the last 36 inches, the surface area is increased much more than the 1 3/4. So the water's slowed down. You've increased your system weight, and then you put like an 1.125 tip on the end of this 2.5 inch section. And now it has to reaccelerate to make the fire stream. And you have about 50 PSI down at the nozzle. So you have 50 pounds of back pressure. And in 2.5, that last 36 inches would have about 280 or so square inches in it. And if you times that times 50, you're going to get around 14,000. And my rule of thumb is if you have velocity between 19 and 21 feet per second and about 14 to 15,000 combined PSI down there, it's a pretty well-balanced system in the big hand line. And you probably experienced that when you put that larger piece on there. However, that being said, it limits your stretch potential. It causes confusion on the fire ground between line selection. It's kind of like I like it as a parlor trick. I can go out and do it. It's kind of a neat thing, but it makes you understand the forces that are involved with making a hose system balanced. And I think one thing that people don't understand is that as velocity in the water goes up, as water travels faster through hose, sidewall pressure goes down. And the way, I guess the easiest way to explain that would be like the old put your boot on the supply line.
Yeah. That's
And
the way I
if it's
was taught.
stopped, you're almost out of water.
Right.
Well, as you drop your compound grade gauge, velocity in that hose is going up as it delivers, as your 4-inch or 3-inch or 5-inch delivers more water, velocity is going up. So sidewall pressure is going down. So now you take something like 1 3/4 and stuff 300 gallons a minute through it, and you leave it all 1 3/4 to the end. And then you put an 1 1/8 nozzle on it. It's going to be like, it's going to be like that famous movie, whatever they call it, 8 seconds, it'll be like riding a bull or something. Right. And that's why that doesn't work. You'll have guys out there, they'll pump 300 gallons a minute through an automatic nozzle, and they'll pin it to their body, and they'll say, see, we can get 300 gallons a minute out of 1 3/4. And my thing is, yeah, sure you can, but can you properly map your advance? Can you keep the nozzle open? Can it be at a good arm's length? It's like a Desert Eagle 50 caliber handgun. Is that really a good handgun? The answer is no, because you wouldn't see, you would see more people own it if it wasn't more than a parlor trick. Or there's another handgun. I don't know if you're a handgun guy. I'm not, but I know some of it. I think there's a handgun that will fire a 410 shotgun round.
The Judge. I figured you were going to the Judge. Yeah.
Yeah. Like, okay, well, why isn't that like the standard, handgun for like high power? There's no aiming, there's no nothing, like if you put a 410 slug in there, yeah, good luck. And the FBI's figured this out. The FBI weapons study, they encourage the entire law enforcement community to go to a larger caliber round, and 25 years later they did a lot more study into it, and they said, mea culpa, we're sorry, we're going back to the 9mm.
Going back to the 9,
for all of these reasons, and we were wrong, which I think is amazing. If the FBI can do that with 40,000 agents or whatever, any large fire department in America can change. That gives me hope.
Gives you hope. Now, I do love the 40 cal. Don't get me wrong. I'm a 40 cal fan, but I carry a 9, so that has the actions speak louder than words. I'm going to catch you up on. I missed a lot of comments already, guys. I'm sorry. So I'm starting somewhere with 8 minutes into the conversation where Kyle Thon. All right. I think this is a question from Kyle Thon. Class A foam, going straight into a rabbit hole. It seems that some of the most prolific subject matter experts on fire attack, including yourself, I'm assuming he's talking to you, make mention of the fact that Class A foam doesn't provide much benefit, specifically in the pre-overhaul stages of fire attack and structure fires. Anyway, Class A foam, why it wasn't a part of the study, and most importantly, your take on the drawbacks in regards to the physics of Class A foam. Do you have anything you want to say on it to Kyle Thon?
Well, he's not present. I don't want to put words in his mouth.
Fair enough.
But Dan Madrikowski probably is one of the reasons it's not more heavily studied. His background in fire engineering, for the audience that doesn't know who this gentleman is, he's one of the lead fire researchers in the country. He's an elder statesman of that. I shouldn't say elder, but time. Let's call it time and grade, or
fair enough.
A greater wisdom on the planet. So he's gone down that rabbit hole in the 90s and 2000s, and he found very little application to it in the pre-overhaul stages of fire. And if you look at Class A foam, probably the easiest way to know that it doesn't have much to do with initial knockdown is that if you take something that is proportioned at less than 1%, and typically Class A foam is done at much less than 1%. We would say 0.5% or 1/3%, 0.3 on the little gauge. If I put 100 gallons of water in let's say 30 seconds into a space, or let's do a 160 nozzle, I deliver 80 gallons of agent into a space that is suppressive. And of that 80 gallons, right, right? So 10% would be 8 gallons.
Right.
Right. 1% would be 0.8 gallons. 0.5% would be 0.4. Right. So we're going 0.4 of its concentrate, and the rest of it, 79.6 gallons delivered, is pure unadulterated water. How can something so small change the dynamics of what water's actually doing? And the short answer is it's impossible. You know, it ruins some of the surface tension. And I'll go one step further. I think cast, for example, especially dry cast, but even sticky cast that's wet, changes the way water rides on surfaces. And I think for knockdown, it's probably negative. It's probably, you know, if it sticks to the surface, I want my water to move around and shatter and go places. And what we're really dealing with in the room is heat initially. So, and I'll tell you why I know this is not an area of science that's under dispute in the physics world. Corley, what is the most research suppression device in the world?
I would say water. I mean, is this a trick question?
No, water. Okay, so that's the agent. What's the device that puts out the most fire in the world?
Come with me.
Fire protection engineering systems, right?
Okay.
Private fire protection systems. So there's a sprinkler.
Okay.
If foam made sprinkler systems, let's say 50% more efficient, don't you think they'd put a little inductor on the riser? Don't you think there's protecting billions of dollars? If you have let's say the average sprinkler fire does $10,000 worth of damage, and if you inducted a little bit of foam in there, cut it to $5,000 worth of damage, don't you think that would be the normal thing on a sprinkler system? We're talking hundreds of millions of dollars over decades. So they've studied it in sprinklers and stuff, and an initial knockdown, it's just not that important. It doesn't make a big difference. So now Class A foam systems on an engine, I will do around the pump foam system depending on the agency. I will typically do the smallest system possible, and it's usually for wildland application or post overhaul application. Modern fuels really burn on the surfaces, plastics and stuff. Class A foam's not the greatest for overhauling plastics, but cockaloff fire, big attic, you go down to the lumber yard and you've done the initial knockdown and you want to do something, and you're not going to batch mitch in your tank. Now, here's where people get in trouble with foam systems. They want it on all the outlets. Well, what if we play Class A number 2 and number 1's in the fire, and then our pre-connected 2.5, we want that to have foam, give it on our reel line, and let's also put it on a front bumper line, which is very common. People will put it in those reel line, rear discharge is pre-connected, 2 crosslays in the bumper. And then the foam loop's really only designed for like a 500 to 700 gallon flow. There's a lot of friction loss inside of it. So I'll go to those rigs, I'll pull the 2 crosslays in the big line, I'll try to pump it and gate it, and it becomes impossible to run because there's such a pressure differential because of the friction loss in the plumbing, because all of those outlets share the same foam loop, because municipal fire equipment doesn't do a custom injection pump for each outlet. They do a gross foam loop, and they put a single injection pump in it, and everything you spec on the truck comes off that foam loop. So I had a consulting gig in a fire department that had a chief that really believed in foam and put foam on all the discharges, including their large diameter discharge. And from the volute of the pump to the 5-inch discharge, before flowing 1,500 gallons a minute, before the water ever left the doghouse of the pump body, there was 80 PSI of friction loss in the system.
Wow.
So he built a rig designed not to move water. And so the manufacturer who built it left 3 discharges with no foam on it. Why do you think they left 3 discharges with no foam on it?
Because they couldn't meet the requirements, probably.
They had to pass the annual pump test,
Right.
and they had to pass the UL test. He wanted those outlets to have foam on it, but the manufacturer said they couldn't do it. Right. So it's kind of one of those things, like, it's not what you don't know that gets you in trouble. It's what you know for sure that just ain't so. I think Class A foam for structural fire at best is studied in the small compartment realm. And when you look at knockdown, there's really no statistical difference. And then there's obviously the cast study that just basically shows that. And that's people go, well, Class A foam has water in it. And notice that all the cast experts over the last decades have made their casts wetter and wetter and less air and wetter. Why do you think they're making, all the cast instructors have made their cast solutions less air and more water?
Yeah, it's just water works.
It's because water works. Yeah.
Yeah, I love it. I love that.
Yeah.
And if you ask me an open-ended question, I'm just giving you a fair warning. There's no telling what answer I will come up with, just so you know.
Don't ask questions you don't want the answers to, right?
Everybody, if you asked a question, guys, there's already been like 100 comments go by that I have not been able to look at. And so Robert Ramirez, I love you, brother. He says, taking all the notes tonight, 100%. Daryl Liggins says, yeah, it's not true. He's answering someone. I'm sorry. I'm not reading the answer. Let's get to scrapping 2 questions. Let me see if it's a good question before I just rattle it off. All right. Nicholas Morgan wants to know, and you probably get this question a lot, so I apologize. What's your opinion on 7/8 versus 15/16? Does the difference of 25 extra GPM really make a difference, and go?
Well, the short answer is, of course, right, on the deliverable. Like, if you can deliver the extra 25 gallons a minute, it'll have greater extinguishment. The higher the application rate that's actually properly delivered, the less amount of water you will use, right? So, like, if you have a campfire and you have a 5-gallon bucket and you can dump 5 gallons directly on the campfire, it's going to be more effective than 6 or 7 gallons. Let's say you have a 10-gallon bucket, but it's heavy and you spill some on the way, and when you toss it, it doesn't quite make it where it goes. I think the better question for the American Fire Service is, why does the 15/16 exist? And what's the legacy there and the history?
Nice.
Because if you don't know the history, you won't know the crucible that created the solution, right? The mother of invention is necessity, right? So is it necessary, right? And I want to maximize life and property preservation on the fire ground through the functional application of water. So I'm looking at end results. I don't really care about efficiency. I'm looking for success and suppression and life safety and property preservation. People go down these rabbit holes about, like, I've never come out of a fire when I've pumped as an engineer and given nozzles a high five because they only used a quarter tank. Like, to me, it's like quarter tank, half a tank. I don't care.
Right.
Is the fire out, right?
Right.
So, like, there's metrics that people use in their heads that really have no, scientifically minded people have these metrics in their heads about, like, water's precious or blah, blah, blah. So, and then there's the other side of the equation where it's, if everything looks like a nail, eventually you're going to hit it. You're going to hammer everything, right? Yeah. So the 15/16 I think is pretty interesting. Someone from FDNY with an R&D history of that organization could probably weigh in it in more detailed fashion than I can. I spent some time at their fire research library when I was trying to make hose more to my liking and hopefully the fire service's liking. And I really kind of always wonder, like, when did the 15/16 come about? And it's definitely an FDNY derived tip as far as I can tell. Now, here's something. The 7/8 predates the 15/16. Like, it's historical record, 7/8 existed before 15/16, and so did the inch tip. The inch tip existed. So as far as I can tell, New York's one of those agencies that predates 1 3/4 hose. And they had this huge ramp up of fires in the starting kind of late 60s through the 70s and early 80s. And around then, they were introducing some smaller hoses to the FDNY, including 2-inch. There was a 2-inch pilot. There was also a really big corporation involved that was a consulting company called the RAND organization, or they did the RAND study in New York. And there was also, guess what, a wet water and foam pilot system there with around the pump. Some people say it was sabotage. You know, there's all sorts of, if you get into the nuts and bolts of it.
Right.
But I digress a little bit. So now the 15/16 tip. So all of a sudden the small hose gets out. And if you talk to somebody like John Norman, when he came in the FDNY, he told me there were companies that were like, there was company officers that are like, we're never using that 1 3/4. That's ridiculous. 2.5's worked forever. You know, whatever. It's on the rig, but we don't use it. Not in this house. And in New York, you could tell there was some culture there, a very detailed look around water movement. And the way I could tell this is true is the 1 1/8 tip, which has just been upgraded to 50 PSI to my understanding in the new engine book, was traditionally operated at 40 PSI. And my understanding of the history was before 1 3/4, the reason they ran the 1 1/8 at 40 PSI was to make it easier to handle inside residential structures. It substantially lowered the nozzle reaction, and they didn't worry about kinks because they could put a guy on the nozzle, a guy behind the nozzle, and a person per coupling and per corner, right? So now, those 6-person engine companies, officer plus 5, the 15/16, this small line comes in to New York, and all of a sudden they're like, they have 7/8-inch tips, and they're like, man, we're going from 250 gallons a minute to 160 gallons a minute. Like, that's a big cut, right? And then someone probably smart said, 140 gallons, 240 gallons really, but that's still a huge drop in gallonage. How can we do it? Now, some of the companies ran inch tips on their 1 3/4 at a lower pressure as well. So there was all these mixtures of tips and pressures in New York. And I don't know which company did it first, but somebody bored out a 7/8, a 16th over, and that became part of the New York mindset in certain areas. Somebody then down at R&D knew something about the Freeman ratio because they wrote their own hose spec, and right around there, and New York hose was born, 188, which is half that is 15/16. Now back to the 25 gallons or so of extra water for extinguishment. So they had a couple cultural things going on. They were vastly reducing their flow from what they were used to, and they also have a built environment that's very different than most of America, other than other large cities. Their exposure problem is much greater, and their capacity to deploy hand lines in a building is much lower. They have a lot of people on the fire ground, but a vast majority of work is done in buildings where you have to enter through a stairwell. So, Corley, how many lines can you deploy in a stairwell?
Effectively?
Correct. We're talking about not theoretical. Right. I get in trouble for people saying it's theoretical. Dennis, it's theoretical this, theoretical this. Effectively or functionally, how many hand lines can operate in a stairwell?
I would say 2. It'd be like the functionally. Go ahead.
That's correct. You came to the same conclusion that everyone comes to that operates regularly in stairwells. Now there's only 2. And if you read the engine book in New York, which I was a big fan of, I read it in the 90s, it said if you need a third line, it has to come from an alternate area. So it either needs to be rope bag, coupling dropped, New York hooked up, or whatever. Maybe there's another stairwell in the building. All right, so now you have all these people on the first alarm. Let's just say there's 60 guys or something, 50 to 60 guys on it. And I'll tell fire chief, how many hand lines can the fire department of New York stretch to this apartment fire?
Right.
Right? It's different. And then I go, if you pulled up and you were resource rich, but access restricted, and then your exposure problem, let's say you had a fire on the 3rd floor and it's a 6-story walk up and there's like 6 units per floor. All right. So there's 18 homes above the unit that's on fire. Would you err towards just enough or having some tactical redundancy? You have an access problem, you don't have a people problem, and you have a huge exposure problem, right?
No.
So you don't have a problem with putting lots of people on the line. So they can deliver that 25 gallons a minute, often much better than other agencies because of staffing. They have a unique problem where their exposure problem is very high in a lot of their fires. A lot of their stretching is done dry, right? Up, whether the hallway's clean or not, whether you're staging the floor below or not. And then they have a huge access problem. If they don't get it with the first hand line, it's often difficult. If you have 2 lines operating on the fire floor, how do you get a line above? So that target flow is kind of for agencies that have really good staffing, substantial internal exposure issues, and often operate in stairways. So when I consulted kind of with Seattle, I did a lecture for their officers thing. I never did any official consulting there, but I talked to like Aaron and Casey Phillips and Phil Jost. Like, that's an agency that I think makes sense. Maybe they should still be in a 15, 16 for that 185 flow. If I go to Consuma Sacramento, where I consulted, and I look at their staffing and the type of fires they're going to, they absolutely should be in the 7/8. So, it's just one of those things where you have to know the history, and then you have to look at realistically at the type of staffing and fire they have to come to a reasonable conclusion.
Oh, I love it. And it's all about like how many people are going to be arriving on scene and handling this hose line and this package, and what are they going to be attacking, and what are their priorities going to be? And you've got to match that. I mean, I'm trying to melt it down, but
I strongly believe that the small handline attack package should be able to be operated in a continuously open position and shall deliver between 150 and 185 gallons a minute in that 40 to 60 PSI nozzle range, 77 feet per second to about 90 feet per second, because you're going to have kinks on the fire ground.
Sure.
You're going to have times when you need to half bail to make the corner or something like that. So, that's the target you're shooting for. Do I think if you get to a room and contents fire that isn't structural, is a 20 gallons a minute going to make or break you? No.
Right.
Do I think if you have the staffing and you have all the restrictions FDNY went, you should step back to a 7/8? No, I think they're where they need to be. I would, sometimes I make these comments that are taken out of context and people get offended.
No way.
I would say that if I was in charge of the FDNY pump chart, I would return the per length friction loss to 15 on the FDNY spec, because I think their lines are commonly over pumped, and you can see at times it's a hell of a lot of water. It's a struggle, for them.
Nice. Hey,
I'm sure I'll get shot later.
No, you're fine. You're great. All right. Daryl Liggins is throwing a question at you. I want to throw this at you. Dennis, what would a Dennis LeGear engine hose bed look like? What would a Dennis LeGear engine hose bed look like? Attack and supply and nozzles. So Liggins is not holding back. He's throwing it at you.
Well, I think most of America is county protected and suburb fire departments. So I think those agencies should have beds that look very similar. Part of it's driven by the infrastructure that's in the ground. Those cities that are newer or, built since the 50s, they're going to have water main infrastructure that's very similar. And the American Water Works Association, kind of like the NFPA for water departments, or the way everything is done. I pretty much know what's going to be in the ground there. So, that being said, there's different locations you can have the hose on the rig. I'm not a huge fan of crosslays. I think, if you work in a bedroom community where you have no ladder company, and the setback to the door is exactly 30-40 feet, and you can line the cross lay up every time and you're not going to be blocking anybody, you probably should be in a triple fold and have a cross lay. But, you know, I don't design things for one thing. I design something that should work holistically. So, you know, a Dennis designed engine predominantly will be an all rear hose deployment model. If you want options from the front of the rig, that's fine. I think cross lays, you're sacrificing so much in length, compartment space, and deployment methodology in cross lays. I see it as a net negative. Now, that being said, the two attack handline sizes would be 1 3/4 and really, really close to 1 3/4. And it would be a target flow of around 150 gallons a minute to 160 gallons a minute. Preferably solid tip, but fog nozzle is more than acceptable on the small attack package. But if you have a fog nozzle, you should have a clear policy of when you don't run it on straight stream. And then large attack package for me would be 2 1/4 inch hose with a 250 gallon target flow, and it would be a solid tip. I think large attack handlines are often applying water from the exterior to the interior initially, and there's big advantages, I think, to solid tip nozzles there. And then on the supply side, there would be a bed of 3 inch. And it might even be a split bed of 3 inch, like one pre-connected to a RAM monitor and the other side of it open for FDCs or suction to suction connections. I really believe in low side connections for gridding out supplies and attack engines. And I think if you plumb your auxiliaries correctly, it's a very nice thing to do in 3 inch hose. And then for supply in the suburb fire department, I strongly believe if people understood water main infrastructure, 4 inch would be the common solution. And again, it would be a split bed. And if you build an L-shaped tank or an upright tank up front, and you really lower that hose bed down, you want your supply hose, your 2 4 inches, to be in just single columns. So it would be, and I kind of have different thoughts on this. It drives me nuts. Corley, where's your supply line on your rig at work? It's center, like right, or left?
No, it'd be right. Yeah, that's right.
So on the far right,
facing the rear.
All right, how many wide is it?
Oh, it's probably 7 wide. I'm guessing. I'm
7.
Ballparking.
7 wide.
But well, I'm not gonna lie to you. It's like 9 feet up there, though. It's up there. So sorry.
Yeah, I don't know the agency you work for, but a lot of times people put supply hose in the dead center of the rig.
Okay.
And then they go, oh, it's for weight or balance, and then it'll be like 4 or 5 wide, and you get this when you lay your supply line down the street, don't you? Get the big lazy yes?
Oh yeah.
That's because it's really wide.
No, you're not lying.
Right. So like if I can design a rig where it's low, and that first column, the hose that's going to come off first, is on the far right side, and it's a single column for 500, and then it flips over and does the next 500. What do you think the supply lay looks like?
Yeah, it looks a lot smoother. A lot
straight as an arrow. Truck can drive by. You can deploy it on one side of the road, right? So then that 4 inch for residential flows, if you look up in the NFPA standards now, they have a recommended residential flow, and it's only continuous 500 gallons a minute. 500 gallons a minute in 4 inch hose is like, it's less than 8 psi. It's probably like 5 psi. I don't know. Let's see here.
Get the actual.
800 gallons a minute. Oh, so I said 500, right? So 5. I'm like, why is it so high? I was like, I lied. It's exactly 5 psi.
There you go. I trusted you.
At 5 psi, if your residential hydrants typically run between 50 and 80 psi, and you want 10 pounds on your compound gauge or something, so you have 50 psi, right? To deal with, 5 times 10 is 50. You can do 1,000-foot lay away from your hydrant and still have a full 500 gallons a minute continuous. So why would you want a size bigger than 4 inch? The answer is you don't. You don't need it. Now, the other nice thing about 4-inch hose is that you can drive over it. Now, when I kind of had this discussion with Seattle, Chief Joseph was, I believe, at training at the time, and they went out and did it. They did it with guys on the line, guys off the line, supplying master streams, not supplying master streams, because Seattle is a truck light fire department, and often their trucks are showing up late. And one of the things I was talking to Chief Joseph one day, I said, why aren't you just driving over it?
Right.
And 5-inch hose, guess what? Can you drive over 5-inch hose, Corley?
I'm guessing right now from the way you're talking, you cannot.
No. What happens is that if you look at the diameter of the wheel, when it hits, it's a little too high on the radius, and it skids in front. And once you push it a couple feet and a lot of pressure get on those couplings, it pulls right out of the coupling. You lose. There's so much force involved. The other thing is, from a Stort's fitting from outside to outside, it's about 7.5 inches. And a lot of rigs now don't have 7.5 inches clearance. You can't even straddle it. And worse yet, in the commercial zone, 5-inch hose doesn't meet the 6-inch connection the hydrant has to the main. It's too small. So as more hydrants get used in commercial and residual zone pressure goes down, 5-inch is essentially too small. So 5-inch to me is like 2-inch hose. It's on the supply side. It's way too big for bread and butter and too small for Armageddon. Now, the beauty of that bed I just described in 4-inch hose, if you do 5 and 5 and then you put a 4-way valve on it, and you can drive away from a hydrant, and on the commercial fire, you go, oh shit, I'm leaving somebody. We need good water right away. I have a 4-person rig. It's one of the times I might advocate for leaving someone. Maybe your second gear, the first engine's already there. You drop the 4-way and you pull both. Now you're laying away 2 4-inches. Well, 2 4-inches is equal to 6-inch. But the nice thing about this evolution is you're going to have one wet, one dry. So let's say you lay 200 feet away from this hydrant, commercial hydrant distance 300 feet. Engineer calls for water, where they're going to have about an 800 to 1,000 gallon minute supply right off the bat with just the 1 4-inch, right? Okay. Now you have the 4-way on the hydrant. As you strike a second alarm and second alarm companies show up, you can assign them to the hydrants. Now you're going to have a weld hydrant and 2 pump 4-inches. So like I just helped the county spec an engine, and I usually do 2 large diameter discharges on the officer side. It's very cheap. I don't think they need to be bigger than 3.5. You can do a full 3.5-inch ball valve and a right out 3-inch, and it's not very expensive to do. And it's going to be a rig that can either pump dual 5-inch or dual 4, but dual 4-inch, you can drive over it. You can get a long residential layout of it. It has plenty of capacity, and it doesn't take up as much room in the bed. Like 5-inch is a bed hog, and then it was like, hey, put a bulk bed on. We have no space. Well, it's because you're in 5-inch hose. So,
right.
So that would be the ideal to me. Like the vast majority of the fire service should be in that kind of setup. 1 3/4 around 150 gallons a minute, 2 1/4 around 250, 3-inch for your rams, your suctionless suction, your FDC, your pump supply, your rule driveway, your tender. That's another thing. It sounds like you might work in an area that's a little rural. Is that true?
Me, no. We're completely suburban, but we did have a chief that spec'd our trucks that came from a rural background.
Oh, okay.
So we got the dichotomy that really doesn't match up sometimes.
Yeah. A lot of people will lay 5-inch up a rural driveway, and then they'll have a tender show up. They'll put 800 feet up a 5-inch up a driveway, and the first tender shows up with 2,000 gallons, and they'll put 800 gallons of water in a hose. It'll never see fire. It's just stuck in the hose.
Just in the hose.
And you could have just done 3-inch. 20 psi per 100 feet. That's only a pump discharge pressure of 160, and you would have 2/3 more water actually be deliverable to the fire if you use 3-inch. And 3-inch ain't going to block any later arriving companies. So it's like,
So in short, you're a fan of the 3-inch, and you're not a fan of the movement to the movement towards the 5-inch LDH or the above ground main.
Oh, I think the guy who sold 5-inch is about as qualified as a guy who sold asbestos to the world.
There you go. That's pretty clear.
his kids went to Disneyland. They had a good life, but I don't think it did anyone any favors.
That's fair. That's fair.
Yeah.
Hey.
So he said most common misunderstanding. That was one of the questions you wanted to ask.
No, I'll get you. I'm gonna catch up. I want to catch up real quick because I want to involve the audience. I'm sorry.
All right.
I haven't got to include it, but I do want to get to the most commons because Steve Robertson said, "Hey, make sure he understands he's talking to firemen," and I think you get that a lot probably from Steve, so it's all good. Yeah, dual 4-inch. I'm just checking. Sure, guys, to the audience. There's been so many comments and questions go by that I haven't been able to catch because I'm like literally enthralled with what Dennis is saying. Have to catch my. All right. Rob Fisher is catching his flight. He was listening to us live, but he was at the airport.
Rob's good people.
No doubt about it, brother. One of the best. There's some happy Christmas. Okay, I'm catching up because there's a ton of comments. So, Daryl Liggins, Merry Christmas, brother. Yes. Late to the game. Did we talk about Dennis' opinion on long attack lines over 200 feet? I'm sure we'll get there. Okay, I'm catching up to live. All right, now, common misconceptions. So I'm kicking it back to you. I just want to make sure I didn't leave anything out. And, guys, there was questions I wanted to ask that I marked with hearts. They're gone now. And now we're back to Dennis, so go ahead.
Well, you said common misconceptions, like one of the things you wanted to ask the general question. And that 5-inch, I think, is a common misconception. You know, like I think people who talk about 5-inch hose, you know, fire departments will have a fire. If I do a hydrants to nozzles consultation, one of the things I try to set up is a meeting between the water purveyors and the division chief and battalion chiefs and whoever is involved in the study, and have them go over some fires where they thought they were out of water. And you have water supply engineers in the room, and they're very proud of how they manipulated valves or increased pump pressure and stuff. And then I'll have them go to a whiteboard and I'll have them draw on the board how they laid their equipment out. And always the water supply engineers, you can see the light bulb come on. They go, wait a minute, you didn't have your pumps on the hydrants? You like laid 5-inch away and you were doing stuff around there? Like, you had all these other fire engines on scene. Why weren't you pumping water down to them? And what instantly is obvious to the water supply engineer is that you expect fire flow at the end of your 5-inch lead, and fire flow is only designed at the outlets of the hydrant. And if once you get to a very high volume of water in that zone, you lose the kinetic energy to force water down the hose. So that's why the steamer outlet's called the steamer outlet on a hydrant. It's because when they design the system, they expect the steamer to be there to push it fire flow at large incidents. So I think one of the common misconceptions is that pumps push water, they don't pull water. And that, you know, commonly at large greater alarm fires, the American Fire Service is treating their steamers like city buses. They're just driving them to the incident, which is a real shame. And it typically, if you go out and run a large drill where you have, like, I'll go to a fire department, they'll set up at their drill tower and they go, look, we can do this evolution all day long, get 1,200 gallons a minute out of our tower ladder. And I'll go, hold on a minute, and I'll run down, give me a hydrant wrench, I'll run down, I'll open 2 other hydrants in the zone. I'll just drive down the street and have them dumping on the ground, and they'll go like, oh, we can only get 700 gallons a minute now. And I'll go, let's put a pump on the hydrant. They're back to 1,200 gallons a minute. All water supply evolutions that are drilled on should be drilled under realistic conditions. And realistic conditions is more than one hydrant's being used. Now, water departments don't like it. You're spilling a lot of water, especially on the West Coast and the droughts and stuff. But if I'm on the East Coast, like the few times I've done a full hydrants nozzle class in Richmond, Virginia, a hot one, the light bulbs have come on, and you can see the way that fire department operates at fires now, that they commonly are putting pumps on hydrants and welling hydrants, and you know their culture has changed. So right that's on. Another question. You say culture versus equipment change.
Now I want to dig down real quick and ask you about 5-inch real quick, because like if you're a department that has just dumped their budget into switching to 5-inch and they're married to it for the next 10 years of service life.
It's very, you should be buying hose in rotation, like every 5 years. you should replace like a third of your hose fleet, right?
Yeah.
So then the city manager doesn't panic, or the
Just
county.
freak out. Sure.
Most people do that incorrectly, So, perfect example of like what I consider, this is going to probably get me in trouble again, but like the Houston Fire Department, within the last 8 years went to 5-inch from 4-inch. Okay. And they essentially had split beds of 4-inch. What they were lacking was 4-way hydrant valves and training, right? So the incident commanders I know from the training side of my life, the Mo Davises, the Clyde Gordons of the world, if you ask them, they'll say, worst thing we've ever done. We should have stayed in 4-inch. We should have just put more pumps on hydrants. Well, dual force is hydraulically much more effective than a single 5. And then if you have dual 4s and a pump on the hydrant, it's way more effective. But then people go like, well, won't dual 5s be even more effective than dual 4s? And I'll say yes. But the hydrant's only connected to the main by 6-inch pipe. Dual 5s is 7.5-inch pipe. So putting 7.5-inch pipe above a 6-inch connection, does that gain you anything?
Right.
And the answer is no. What it does is it ends up taking up a lot of space in your hose bed, and it takes things off the table you want to do. Like, let's say you want to put a bulk bed in there and you look up and you have all this 5-inch. Richmond, when I was consulting in Richmond, Virginia, a lot of the companies, they were in 4-inch. A lot of the companies were carrying 1,200 or 1,400 feet of 4-inch hose. And in my report, I said there should be no more than 800 feet of 4-inch hose on a Richmond rig. I'm like, you have 4 engines coming to every alarm, and they took me to a couple areas of the city where they go like, look, this house, to get a hydrant supply to this house, you need 1,200 feet of hose. And we wheeled it out, and I said, yeah. And it would be like one house, little house in the prairie, in some field next to some industrial lot. And then I'll go, well, who lives here? The president? Are you doing everything in your entire department around this one house? And now you don't have bulk beds that can be used all over because of that? And then it would be like, what's the best way to attack this house fire down this gravel road in the middle of Richmond? It's probably to go straight in and use tank water. And then the next engine probably to do that. And then the 2 engines that are left over, if they needed to make a long joint supply, they could. Right. So it's, I think outside perspective is golden. And then you have to take, as an agency, you have to look. You said one of the questions, culture versus equipment. Yep. And I gave that example in Richmond about them now putting pumps on hydrants. They actually have 4-way valves. There's like a thread issue there they got to solve with their water department. So they knew they needed 4-way valves. Like I went there and I was like, why aren't these on the rigs? Right. Some people said, oh, it's too heavy, or once we threaded on a hydrant, it fell off. Well, identify which hydrants have the older Richmond threads, and the water department says it's like less than 3% of the hydrants. And I'm like, fix it. Without pumps on a hydrant and a heavy commercial flow where you've laid 5-inch out and you've laid away from the first 3 to 4 commercial hydrants, you're giving up about 50% of your supply.
Nice.
So, it's 50%, that's a lot of water. So if you got to a fire and you only could deliver 4,000 gallons a minute, if I went back to that same area, put pumps on hydrants and set up a little bit different, it would typically yield between 7,000 and 8,000 gallons a minute available. Right. You might not need it.
Right. And that's the thing. And that's probably some of the pushback you get is, when are you going to need 8,000 gallons a minute? Well, the only time you need it is when you need it, So
to me, if you set the things up, if you practice in a way that will always achieve the best water movement, it doesn't matter when, it's if, right? So 100%. Sean Gray, great guy, Cobb County lieutenant. People have had different opinions about him in the fire service. We've had our disagreements. I liked to travel. I would be calling Sean Gray from, Paris. I'd be taking pictures. I'm like, how can you hit it hard from the yard here? Or, I'll be in some other metropolitan area and take pictures, and he's like, well, that's not my normal first do. And he has points and I have points. But one of the things in the UL Burns in Cobb County during the coordinated attack study, he was a nozzle firefighter in the off-plane down basement simulation where we did a ventilation above them. So we had open flow vent above them. They entered in the middle of the chimney. It's one of the ugliest things I've ever seen on video. It's chugging out. Like I thought, like, they're probably not even going to go in.
They're like climbing down a unidirectional type deal.
And they went unit. It was 100% unidirectional with the living room off and 2 90-degree returns to get water on seat.
Wow.
And I went on record before the fire. I said, I don't think anyone's going to make it down these stairs. And they said, well, flow and move. And I'm a flow and move guy. And I'm like, I don't know. It just seems like it's not gonna work. I've been to fires where I got to back up and they weren't even downhill like that.
Right.
And I'm like, well, we'll see. And he said he was a big hit and move proponent as a board member on the UL advisory board, and we would have disagreements back and forth. And I said, it's not if, it's when. I said, you're going to have a fire where not only are you going to have the nozzle open just to remain safe, I said, you're going to have to not have the nozzle open just to back up.
Just to get out. Get the hell out.
You'll get burned. So they practiced it. They listened. The UL's very good for me. I believe, the fire attack study or interior study, they listened and they were going to do an interior study anyway. I think they put together a really good panel on that, which I happen to have the privilege of being part of. But he said he got in and they didn't even make the first turn and their gear was totally saturated, with the nozzle open. And they said, man, we were afraid to shut the nozzle down. We had to back out. They had a whole nother crew waiting, the A team. Now let's try those guys. They didn't get any farther. You know what I mean? Their gear got saturated.
Sure.
So, same on the supply side. Like people go, I don't even know if I would teach hit and move anymore I would, to me, that's a more technical skill. You need to know when it's okay to use. To me, it's like, you shouldn't feel heat in your gear. When you lose visibility and you're headed towards a fire, open the nozzle, use the sound to try to orient yourself if there's a hallway or something down there. I didn't have the advantage of tick, flow and a pattern, flow and move down there. The data is best from flow and move. So guess what? The new studies are all flow and move.
Yeah.
It makes perfect sense.
Dude, I love just that little sound. I had to find a pen to write down. I had to sound stamp it because that's a great sound bite, what you just said. 100%. Now, we're getting into this, so I'm having a blast. Hope you are too. If you get bored, let me know.
No, I just I looked at what we want to talk about. We're all over the map.
No, dude, 100%. And that's the thing is I hope you don't mind the chaotic nature of the scrap because the audience gets to throw their questions at you, and then you get to take it whatever direction you want. But here is one that I'm going to take control of and ask you because this one thoroughly intrigues me. And you said it in the notes when you sent the email to me. You said you wanted to talk about what is missing from the fire triangle when talking about water. And so I love that statement. I want you to explain what you meant by it.
So during the fire attack study, and if someone looks fire attack study, they won't find it. It's a big, long, lengthy name. It's interior attack and tenability and occupant survivability,
and rescuer, blah, blah, yes.
And rescuer or something, everybody just calls the two studies are the fire attack study and the coordinated attack study. And they had already done a ton of research, mainly without applying water at the same time. And then once they applied water and did ventilation, then they wanted to know how to coordinate it. So I kind of feel like I lucked out and got on the two that really were my passion to begin with.
Sure.
But also I think where it wasn't, we haven't had a really good discussion in the American Fire Service around what water does. And I think where I really got a sense of this was from wildland firefighting. And, from the early 90s, to about 95, 96, I did obviously deploy, when I was in Oakland and also in Kings County to wildland fires, but wasn't my primary duties. But I was in forestry. I was in CDF before they called it CAL FIRE. And one of the great advantages to fighting fires from the outside in vegetation is it's field observable. Like knowledge, a lot of learning's done through observational changes from the actions you do. And so if you look at like fire weather, there's like the 18 orders that shout, watch out. They were 13 when I started. And then there was the fire orders. And now there's the WUI, the wildland urban interface, the 4 common denominators. They keep adding them up. But one of the things I think in fire service has had over the structural fire service for years is they could see the terrain. Like, don't attack from above.
Sure.
If you can, right? And it's like, oh, okay, well, what's all this flow pass stuff that we have now where you have walkout basements and guys getting roasted in the chimney and stuff like that? It's like, oh, well, that was observable in the wildland environment. Okay, so one of the things, I worked in a light, flashy fuel area of California, kind of California Oak and Chaparral, I was south of Yosemite. I was right outside of Kings Canyon.
Okay.
Sequoia National Park in Tulare County. And we would sometimes roll out in the valley and we would be in waist deep, seeds of grass with oak and chaparral. And then we'd also have this brush that could really get on fire, chamise. And so you would anchor your rig in. You'd get to like a paved road or gravel road or something that's down to mineral soil. And you're either going to make a mobile attack where you drive your rig out into the grass, or if you can't do that, you're going to do a progressive hose lay. And now if you're going to do a progressive hose lay and the fire's outside the reach of your stream, one of the things they told you to do was, have your nozzle open early and wet your advance. Like you get the ground wet by your feet and you walk into the grass and you're going to wet your advance and then you're going to use the reach of your stream, wet your advance, use the reach of your stream. And you're walking through this wet grass that you've wetted. Now, why do you think you wet the fuel that you're walking through, Corley?
Just for that heat absorption, right?
Well, it's preheated. It's been in the sun. It's the middle of summer. Has very little moisture content. So if something goes wrong, the wind changes, it has an ember goes behind you or something like that, what's going to happen to the fuel behind you?
Right, it's going to light off.
It's going to light off. So if you have a wet line that you've made, right, and it lights off on the right side of the wet line, you can what?
You can book
Retreat the opposite direction. You have some defensible space to get back to your safety zone, right? So then once you get to the seat of the fire, you're going to apply water directly on the fire. So essentially, what's that water doing to that dry grass? It's removing it. It's removing it from the fire triangle. Because what's the fire triangle? What's the 3 sides?
Yeah, we got our heat, fuel, and our oxygen, right?
Yeah, your heat, fuel, and your oxygen. Now, if you're on a hand crew, right, and you have no water, you use a McLeod or a Pulowski, and you work together, and you remove the fuel down to the mineral soil, and that's a way you can let the wildfire. You can remove no heat. And you can mechanically remove the fuel.
Right. And
the fire will bump up against your line and go out. Now, move this to the structural fire world. In my early meetings with Andrew Fredericks and Jay Kamela, and Oakland was an 1.5 line when we went there. And there was a guy named Tommy Simpson, a guy named Lyle Elvin. When I talked to them, they're like, keep the nozzle open. And both of them told me, run the nozzle on straight stream. What you learned in the tower is garbage. Run it in straight stream, keep the nozzle, make a wet advance. And I started thinking about this. I said, this is a lot like what I was taught in forestry.
Right.
Like, I want to wet my advance because it takes fuel out of the equation, right? So then you look at a modern fuel package and you have this rich, dense smoke that is fuel. Then you have this preheated living room or whatever you're going through on the way. The walls are preheated, right? You have a preheated atmosphere. So now I picture myself in my head mentally, it's worse than the grass fire.
Right.
I'm blind.
It's 360. It's all around you. It's not just
it's
at
all
your feet.
around me.
Yes.
I'm blind. I can't see where I'm going. And I have people telling me, don't open the nozzle till you get to the seat. You use as little water as possible because you don't want to disrupt the thermal balance, right? You want to, and you had the picture in the book of the inversion, high heat at the top, open the nozzle too long, high heat driven down, cold to the top. You've roasted yourself, right?
Right.
And
it's the way I was taught, man.
You can do that with a fog nozzle. There's only one stream that can make conditions worse, right? It's anything other than a straight or solid stream. It's a fog stream because it churns the environment. And I'll get into that a little bit too in just a second. So back to this wet advance, right?
Go.
What is missing from the discussion, right? If I do a wet advance through a living room and I got like a couple bedrooms of fire in front of me that I observed, one window was broken. Let's say they were Charlie side bedrooms and it's slightly wind impacted and somebody comes on, makes the ventilation bigger and it ends up making things worse. Or maybe a window fails on my advances. Nobody's to blame. If I've wetted my advance, right, and I have an adjacent compartment flash, can the apartment that I went through flash?
Well, it definitely has a higher resistance. I mean, there's no arguing that whatsoever.
So you would have to say that it increased the thermal ballast of that room. It would take a lot more energy. A
lot more, yes.
A lot. So, and the way this became very clear to me when I first showed up at the UL is the way they were handling the experiments. They kept hauling all the carpet out and all their carpet padding out, and they started re-drywalling. They yanked all the drywall down. And I was one of the guys that was like, well, doing multiple sets in one structure is very hard. The environment's wet. Everything's changed. And they, talking to Keith Stakes and Robin and Steve, why can't I remember his last name, but the guy
Kerber.
That's the director now, they're like, we have to do this because the data shows that if any of the stuff's pre-wet, it screws everything up. And I'm like, well, that makes sense. That's why a wet advance is so good.
Yeah.
So a wet advance, when you talk about flow and move as an instructor, and you're talking about open your nozzle often and early and apply water copiously on the advance, you have to say that it's doing more than just removing heat. It's removing fuel from the fire ground.
No, you can't argue.
That carpet can't flash. That couch can't flash. Everything's better. It's made everything much more difficult to burn. And by the way, it's not going to destroy anything. It's drinking water. We drink the stuff. Another reason not to put foam in it, by the way. So,
full circle, dude. I love it.
If I had a house and a fire department came and extinguished my house, I would much rather reoccupy my house after they used water than something out of a blue pail in water. That stuff's in the wood. Is it going to dry out? I know water's safe. I know water on straight or solid stream applied copiously not only removes heat, it removes fuel from the fire ground. So it's safe for the advance. It's safe for the trapped occupants. It's the safest way to extinguish. Now, why can we do this? Why can we leave the bale open without steaming ourselves? And I think this is not well understood either.
No, go.
All right. So it's in Dave Fornell's fire management handbook, and I was hoping that they would do a brass tacks on it. I might have been a little late to the gun. They were filming when I was like, have them talk about this. I can't remember what page it's on. I can dig it out, but he has this very poignant paragraph in there where he's talking about 185 gallon minute stream. And Jason Bessel also quotes it in his article from Sac Metro about what the changes they did in Sac Metro pretty much after our changes in Oakland. But if you take a fog stream and you even put it, we had this huge argument at one of the burns, like that's not 20 degrees. I mean, that's not 30 degrees. That's 20 degrees. I said that when they were doing like a 30-degree fog experiment. I'm like, have you ever measured it? And so they got on a computer and they had some sort of program that allowed them to measure
the power cone.
Yeah, they were all, I had the dunce cap on, they're like, oh, it's, 22.3 degrees, Dennis, but to me, it was very important because the only time I've been in structures where things have gone really wrong with either opposing hose streams or lines being open a long time was when they were on anything other than straight or solid. And that was my field experience. I was trying to figure out why that occurred.
Right. Just validating your anecdotal.
So, right. So then go out to your drill tower, put a fog nozzle on what you think's 30 degrees and stay about, let's do something realistic, 7.5 feet, no greater than 10 feet, or maybe even 5 feet, even close, and see the amount of concrete it wets, right? So I'm going to say 7.5 feet or so, maybe 10 feet away, the size of a bedroom. That 30-degree pattern is wetting the entire opposite wall, 10 by 10, 100 square feet.
That seems logical, yeah.
So 100 square feet. If you're doing 180 gallons a minute, right? If you're doing 180 gallons, how many are you doing a second? So it'd be like,
you do the math, not me.
It would be like 3 gallons a second.
Okay.
3 times 60, right? So when you open that nozzle and it's in a 30-degree pattern, and you get 3 gallons spread out over 100 square feet, 10 by 10. How much water per square foot is being hit? That's easy. Move the decimal point to 2 spots. 0.3 of a gallon, 0.03 of a gallon. If I put 0.03 of a gallon in one little square that's superheated, is it going to cool the square or turn into steam?
Right. It's going
to turn into steam. So the 30-degree fog pattern applies water in a way where it's distributing the water over a larger area, and it cannot instantly cool that. So you're always going to get more water. Now, take that same pattern at the drill tower, turn it to straight stream or use a solid stream and aim it straight at the opposite wall. And what you'll see is water sticky. It hits one little square spot, and then it will instantly cool that spot, and water will radiate in a pattern against the wall. So once that spot's super cool, can that spot generate steam anymore?
Right. No, yeah, you're cooling the
0.
Right.
So Aaron calls it's like an eraser. That's like the first time I heard it in one of Field's lectures. It's like an eraser. And not only is it like an eraser, it's an eraser that self-erases. As you move the line, that solid or straight stream against the other wall, it's also radiating in 300 degrees. So once you have a cool spot, it instantly is cooling other spots. Now, one other guy I should mention that I saw a little video demonstration that I use to drive the point home. Don't crack your finest cast iron pan or anything, but he was like, you can go to a firehouse, take the kitchen sink, have the little nozzle that goes straight stream, solid stream, in the kitchen sink, the sprayer.
Oh, yeah.
Right? So you can go like this, fog straight, the little thing is something. You can take a cast iron pan, heat it up, or a pan, heat it up, hit it with the tick, get it to the same temperature, put it under the fog nozzle, and you'll see a ton of steam come off. Go back without changing application rate, just the way it's interacting with the surface, go back and do the same thing, and there's vastly less steam. That's it. Boom. You're done. You got a practical experiment anyone can do. You have a way to measure how much water is hitting per square foot, right? And then you can take somebody in a burn can and you can take a 30-degree pattern and make things very uncomfortable. And in the same heated condition, you can do it in a solid stream and cause no problems. That should be enough for everybody. It's 3 strikes and you're out. That's done.
All right. Dude. Too much. You're making my head. Absolutely, man. I have this question coming at you. I want to hear your thoughts. Can you state your thoughts on WYES, WYES, when they should be used, not be used, should they be used on standpipes or interior at any fire? So your thoughts on gated WYES or WYES in general, and I am going to give you the floor, and I'm going to be right back.
All right. Well, first off, I've written extensively about this, and it was like one of the first things that I really brought up in the fire service. So I think it's 2019, the water supply supplemental, there's an article that clearly states the reasons when you can't use them. Not can't, when ideally you shouldn't use them, right? Then there's also Elkhart Brass. Now remember, this is a manufacturer of the equipment. So the manufacturer of the equipment allowed Daryl Liggins and myself to do a historical explanation of why it works, and then with modern flows, and it's specifically 2.5-inch shows, why you shouldn't do it, because you can't properly pump it. Now, in the written article, there's a lot of tactical reasons I don't like them. Causes people not to focus on the first line. It puts the second line in the same place as the first line, which that might not be where it needs to be. It might need to be the floor above. They have the same stretch potential. Each bundle is 100 feet, so you get the backup line's the same length. The backup line always robs water from the first line. There's all sorts of strategic and tactical reasons why operations are bad. But again, I think I'd be remiss where I don't point out somewhere where I think they're working fine and I wouldn't change it. And so I'll point out the Detroit Fire Department. So the Detroit Fire Department's Y operation, and again, the mother invention is necessity, right? It's the necessity part of it. Detroit has a very high water table, and they have clay soils and a high water table. So their hydrants don't drain very well. They have, they can have issues with frozen hydrants in winters. And remember, there were no radios either for like calling for water. So Y was a big advantage for that. And there's all sorts of reasons why's were in the fire department inventory when small handline got introduced. Like first, there wasn't enough outlets on the rig. There's 2 outlets, the 500 GPM pumper. How do I attach 2 lines off one side of the pumper? Well, it's simple. We have this device. It's called a Y. A lot of this came from forestry to the urban fire service. And I think, honestly, a lot of it occurred right around World War II. We had the younger, healthier men in the fire service go to war. And then they said, who else has fire service experience in America? And they start, hey, this old guy that works in the forest or whatever, this guy used to be a firefighter. Right. And all of a sudden you have guys show up and they go like, why are we pulling 2.5-inch hose for this car fire? Or why are we doing this for this? And like, well, there's other size hoses. Oh yeah, there's all sorts of other options, right? Because they had a body of knowledge that didn't really get used. But Detroit, going back to Detroit, first off, their nozzle package is 125 at 75. So it has a very low nozzle reaction to begin with. Second off, if you look at the way city of Detroit's built, it's like a big suburb. There's a lot of freestanding residential structures, and it's a big, wide city. You have this hydrant problem. So one of their common evolutions, in my understanding, is you pull up, and they have this Detroit bundle on the back of the rig, and it breaks all sorts of rules for Y operations. I believe one side's 3 lengths and the other side's 2 lengths. So one side's 150. Well, that's 150 feet, Dennis, because that might have to go to the Charlie side, or some of these bigger buildings, it might up on the floor above. And then we have the 100-foot length. I'm like, okay, well, how do you pump it? They go, well, we just pump it for the longer line. I'm like, okay. So the other deal is they're only splitting 125 gallons a minute and 125 gallons a minute. And their 2.5-inch hose is like 2.8 inches. It's bigger. They don't have to open a compartment. That Y typically never makes it inside the structure. That's a no-no. Like one of the fire departments I greatly respect, you'll hear them have a water supply issue on the fire ground, and you go like, oh, someone's going to say it on the radio here shortly. And they'll say, hey, someone go check the Y, because it's in the smoke and someone's kicked it or it's gotten shut. So the Y stays outside. The engine goes down a hydrant. They check a hydrant. If that hydrant's working, then they send water right away. Do they need to wait for a radio call? No, because they have the Y on the fire ground. It's in the front, right? So Detroit's a good example of they're a department that's still in a historical flow. Their 2.5-inch hose actually oversized. They overpump the system. So essentially, they probably flow 140 out of one line, but is anyone going to complain to 140 on a 125, right. 75 nozzle? No. Then they open the other line. Maybe they're both at 125. That's fine. It works. As long as they understand that that's what's occurring, I'm fine with that. The thing that's great about that evolution is that they're not opening a compartment. They're not making and breaking connections. It's set up. That's the way it's done. Oakland had something very similar to that when Jay Camella was hired. It was called baby lines. It was 200-foot packs, 1.5 inches on a 2.5, and it was pre-finished. Nobody had to make or break or anything, and it was used very similarly. So in that article, I kind of discussed that. But ultimately, the modern flow of 150 to 175 or 180 gallons a minute, trying to split that between a 2.5, and pump it, it doesn't work. And then there's a lot of difference with the way fires develop now very rapidly and stuff. A lot of the Y stuff was historically based. People go like, I talked to a division chief in Portland that retired. He's like, well, I never remember having like a lot of smoke on the floor below. Like, we could hook up the Y, it wasn't so bad. Well, what about now? It's horrible. There's smoke everywhere. It's like, well, fires are smokier than they were in the past, and smoke gets down on the floor below. And should you be making and breaking connections to the floor below? Probably not. Like, it's not a good idea. So that is one of those things where you said culture versus equipment. I personally kind of believe this is one that I kind of take credit for is something I got beat up a lot. I had a tinfoil hat. I was naked with the sandwich board on the side of the road. It says "Wise are the death of the fire service." And then eventually somebody put some clothes on me and my tinfoil hat came off. And then someone grabbed the sandwich board and said, "You don't need that anymore." There's enough information there out about this. I think that if you're a modern fire department and you're going for the 150, 185 gallon minute flow, and you're doing a Y operation instead of a bulk bed, or maybe even a long, small line, 300 or 350 or 400, you're doing a less beneficial operation for deployment and rapidly applying water on your lengthy stretches. It's slow too. That was the final thing that changed it in the Seattle Fire Department. When they didn't mind, they were in automatic nozzles. They ended up understanding that there was huge pressure fluctuations and whatever. But when they put a stopwatch to it and they started looking at the tactical problems it was causing, I think that's really when the Seattle Fire Department got rid of their Y operation.
100%. Brian Brush said this: the institutionalization of, I'm going to read this to you so you can enjoy it, of the gated Y into interior operations is the definition of normalization of deviance. In 99% of departments, reference NFPA standards, flow simultaneous lines, and reference line of duty deaths. Bottom line, a gated Y is a quarter turn valve, and nowhere else in the fire service do we accept a potential life-changing compromise not be an obvious visual display. An OSNY for fire sprinklers, but an 1/8 of an inch move cuts 50% flow in gated Y attack packages. So I think he kind of answered.
Yeah, I mean that's a very good point. And Andy Frederick said if you can avoid a standpipe, you avoid it, right? You don't want to shut off midline between the nozzle operator and the pump panel. Who's manning it? It's remote. There's going to be issues with it. It's just one of those things. Normalization of deviance, there's a lot of instructors that go out and teach that. And I always go like, no, you don't understand normalization and deviance. You can't understand what you're doing is incorrect for a true normalization of deviance.
You have to be ignorant of the fact.
You have to be ignorant, right? I think there's enough material out there now. Ignorance has been flushed out of this debate. So now if you're using them, other than in the fashion maybe Detroit's using them, they're outside, they're and all the things, that moves you from a column of ignorance to negligent. To me, it's like using a fog nozzle on a standpipe. Like people go like, well, how often is a nozzle clogged and there've been a large loss of life or property? And I'm like, well, I don't know, but I know if I had $100 million building and the first 2 lines clogged and I burned up $80 million worth of my property, I wouldn't be paying for it. There's enough like that if that occurs, that's on the city. There's enough knowledge that you could prove they were operating negligently. I think there's enough knowledge around gated Y operations now. You can say the way most people use them is negligent.
Daniel Shaw wants to know, have Dennis discuss the reason for carrying specifically 35-foot short sections of LDH. He talked about this at Water on the Fire and blew my mind on the detail he puts into the decision making.
Well, I've become, most fire engines are about 30 to 33 feet long now. And the reason LDH hose comes in 100-foot sections is twofold. First, the couplings are the most expensive thing on the hose. And then secondly, because it's LDH, it takes up the most room in the supply bed. So one of the things when Oakland went to 4-inch hose, I wanted them to be in 75-foot lengths because it would be half the length of the rig and a 35. And then I could do 35s and I'd be good. If I had a rear intake, a front intake, and a side intake, I could pretty much do everything that I wanted. But it became unrealistic. I did the math, the calculation, how much room I had in the hose bed. It wasn't going to work. And it's going to be an odd length. And everybody does hydraulics in length, 50-foot lengths and 100-foot length. So then I did 50s and 25 bundles in my department when I was there. Then as I was consulting, I started looking at this more. And I'm like, I don't know. There's still times when 50 could be a little short depending on need. And 25 often is too short. And then like 235s would always get me to 70 if a coupling was in the wrong place. So then I started thinking about identifying hose. And what I like is a band at the 50 and a double band at the 25s. So if you look, I know everybody's been there. Anyone who's been a pump operator has gone back and they see a coupling away from the bumper and they wonder, like, how far is that coupling away from my bumper? Is my 50 going to make it to my side intake? If I do a 50 here, am I going to have too much hose in the back? If I have a rear intake, or should I just pull to the next coupling? Where am I in this? Well, if you have a double band on the 25-foot sides, if you see the double band laying right there on the tailboard, you know that thing's 25 feet back, right? The next coupling is 25. If you don't see the double band, you know it's closer than 25 feet to the tailboard. Basically most pumpers, if you measure from the eyelet of the pump to the tailboard, it's around 16 feet often. So if you have a 35, it'll get you to the to 15 feet past the tailboard. So if you don't see the double, like that's one of the indicators. I'm a big believer that true type 1 pumping apparatus should have 4 intakes for a variety of pumping evolutions. Like if I teach a hands-on heavy stream fire, I run out of intakes more often than I run out of discharges. But one of the things about nice having a front suction on a swivel, Corley, have you been where you see the coupling? It's like 15, 20 feet back, and you have 70 feet in front of you, right? Have you ever pulled the 70 feet out and made that loop in the street and gone in your side suction?
Try to eat up the slack, yeah.
Right. What's that do to the roadway?
Oh, yeah, it eats it all up. It's all gone.
Right. No one's passed, right? So like one of the things I teach, like if you have 70 feet left in the bed and you grab a loop and it's 10 foot and you go back at an angle till you see a next coupling hit the ground, right? If you have a front suction, you can run by the side of the rig in the loop. The rig's 35 feet. It's 15 feet back, and then you loop it in front. It's only a 25-foot loop to the front suction. So you can eat up all that in one move and not use another hose, right? Other scenario is like you're really tight in and you're at a spot where you want to use the rear intake, right?
Right.
So where does it line up? Those markings mean a lot, right? So if you have a double hash on the tailboard and you have 75 feet back, you go, okay, well, at this moment I can use the rear intake.
Right.
Like I can use a rear intake. So I think 35s, 2 together are 70, 1 together takes you to 10 feet past the tailboard. It also makes it easier to catch a hydrant. And there's some hose spec stuff, like for Key's product line, I personally have found that the Magnum nylon jacketed stuff has a better kink radius than the Eco 10. Like sometimes I'll spec different hose specs for different jobs. here's a perfect example. Do you have a trash line on your rig?
Front bumper line.
Front bumper line. I really like rubber covered hose for trash lines.
I can't knock it.
Right? They don't absorb water. Any oil or road grind comes right off them. They don't hold glass in them, so when you're repacking, you know what I mean, you can rinse it off. And if you're in a freezing environment, right, it's a pretty good hose spec for a trash line. You know, those are the kind of things that I think about for whatever reason. I don't even work in a cold environment.
I love it. And the thing is, like you said, the 35 foot, we have our pony rolls that we carry on both sides of our rigs are 25 and 50 foot. And there's no thought I mean, maybe I don't want to sell people short. There probably was thought process that went into it, but I really think the process that went into it was, well, we get 4 of them, we get 25s, we get 4 of them and 2 of them at 50. So we'll just chop them up, put the couplings on them and go from there. It wasn't thought out on the length. It was more about dividing up the 100-foot section.
Markings on LDH hose for 50s and the 225s are game changers, and having 4 intakes are game changing too for rig dynamics, especially front intakes. Front intakes, if you have 2 engines nose to nose and you want to share water, front intakes are amazing. Front intakes, I wasn't a huge fan until I started messing with them, and I'm like, man, I'm a victim of my culture. We didn't have them anymore on the rigs that I learned on, and now that I've used them and thought about it, I go, God, these are really valuable pieces of equipment. That I changed my position.
Hey, that's the beautiful part about being able to do so. Now I have this on good authority, okay? And by good authority, I'm saying it's Daryl Liggins, Oakland Fire, and he's a gentleman in the fire service. But he says that you are, in fact, a very big foodie, and you travel the world, and you eat a lot of delicious and exotic foods. But what I wanted to ask you was, what are your top recommendations or / most memorable meals?
Well, if we're going to relate this to the fire service, probably, if you go to a fine dining establishment, it's not going to be like the Cheesecake Factory, right? The Cheesecake Factory is like, well, this guy wants Thai food tonight, and this guy wants this and that. And is it edible or decent? Sure, everybody might walk out satisfied, but it's not like going to a very place that focuses on one thing. Okay. So there's a very famous guy who does Vietnamese food in Portland that, and he's a white dude. He lived in Asia and everything, and he just does one type of Vietnamese food, and that's an example of that. So a lot of things that I like are simple, street food. So I spent a little over a month in China with my father around 2004. And we hired a guide. We went from Shanghai to Beijing, and I wanted to eat whatever was edible that wouldn't make me sick. So I'm talking to my guide, and he goes, well, any street food vendor that has a long line and any ethnic, non-metropolitan area, it's totally safe. He's like, the water might not be safe. Drink bottled water. I just chose to drink beer the entire time. Okay. Time I was there, it was 8 yuan to the dollar, and you could get a quart-sized ting sao in the rural area for 2 yuan. So for 25 cents, you could basically have 32 ounces of beer. So having safe water was no problem. I just drank it in beer form.
Right on.
You'll go to one place and it's like, well, how long have you been making this? And it's like, oh, I don't know. My mom made this, and then I took it over, and now I'm teaching my daughter. And it's like a steam bow cart in the middle of nowhere. Those are some of the best meals I've had, simplicity wise. And if you look at stuff, peasant food often is elevated in fine dining. Like you can have a crepe and have a really interesting savory crepe with lox and salmon or whatever, but it was peasant food. So if you go to a fine dining restaurant, there's basically two experiences you're going to run into. First, the bill's going to be very expensive. And second, there's going to be very limited choice.
Right.
It's going to be like, it's a master cooking, and he's going to say,
this is what I'm making
look
tonight.
At what's in season, and this is what you're getting. And hopefully it'll be courses. There's a Michelin star restaurant, 2 Michelin star restaurant in Oakland. I haven't been there for years. I've eaten there a couple times. Camise. It's particularly good. And, I want to support the cooking community in Oakland, obviously. But I have found that a lot of the best food, I was in New Orleans and Station 29. I kind of met with them down in French Quarter, and they told me to go out in the cemetery district. And they said, hey, when you're out there, there's a fish fry kitty corner of this Firehouse. All they do is, I think it was catfish. All they do is catfish, and they catch it themselves and they fry it. And it's like, that's the best fried fish I've ever had. I still remember it. It's crispy. It was delicious. Then the opposite experience is if you're in New Orleans, 2 restaurants I'd recommend is Bayona, which is kind of like maybe a couple items on the menu, pretty expensive price point. Then the other one's Two Jacks, which is owned by an Oriental family, but it's the second oldest restaurant in New Orleans, and they just kept the menu.
Right.
You don't have to be of that ethnic background to make good food, right? Like if you eat at a fresh restaurant in New York City, I guarantee you the staff's mainly Hispanic, right? So like this all equates back to the fire service, right? Okay. You don't have to work for a busy fire department to be a good nozzleman, right? You don't have to work for a fire department that has nothing but static beds on it to realize the benefit. You don't have to work for LA or Boston or New York to be like, hey, we should have one of these, right? But ultimately, there's acid, fat, protein, and sweetness, right? What you're trying to do, I think the hardest thing that when I get hired as a consultant is a lot of people think I'm just going to come and copy what I did in Oakland and put it there. And that would be a disservice. No one knows that organization or the built environment and stuff better than the local response. Firefighting is local. Fire suppression is global. Fire dynamics are global. So like I can look at all the local factors and look at your existing equipment and then make really relevant suggestions on how, hey, maybe you're using too much butter in that recipe. Maybe you need more of that, right? You're adjusting stuff, right? So, that's kind of,
beautiful,
food.
Man. It's a great analogy, man.
Yeah. Food's easy analogy to the fire service when you really look at it, especially like when you're cooking in the firehouse, like a well-stocked, a simply stocked pantry in a fire department is golden, right? If you just have like some basic dry ingredients, butter, some basic oils and sugar, right? Like you can basically cook something to eat at all times.
Oh yeah.
Eggs, butter, sugar, and flour. If you have those 4 things and you buy some vegetables and a protein, you can do anything.
No, anything.
Right? So
yeah, it's beautiful.
That's how your engine should be. It should be from that basic level. You just need the base.
Is that the book you're gonna write? Is like, here's the 4 ingredients of an awesome engine company according to Dennis LeGear. That's a good book, man. Do it.
Yeah, I've been asked to write. The problem is the problem with writing books for the fire service is you have to be in the right mindset to do it. I'm just
fair
enough.
There. No. I was just throwing. I think it's a great premise, man. The whole the cooking analogy, great premise. Everybody on the audience, man. I feel like I have let you down a little bit with not getting your questions there. I promise you we'll come back to them and hit them at a later date and type in answers. Dennis, there's a ton of questions coming at you, so I hope sometime you can come back here and look at all the comments and questions that came at you when you have a moment of free time. But I always like to ask, is there a book or books that you think firefighters should be reading?
Again, I'm kind of a victim of I came in the fire service when there were, Dave Furnell's fire management hamstring book was fairly new. You could get it for a cheap price. It's a very good book to read. They're not on there. I guess they can't see me, or maybe they can see me on Facebook Live. This guy, Lawrence W. Irwin, EREN, Firefighting Apparatus and Procedures. Nice. This is an LAC chief, and he wrote for a very small publisher. And, this is a book. If I was going to write a book for the American Fire Service, this book, the first half of it is engine apparatus policy and procedures, and the second half of it is truck. And the city of Oakland only had it on the pump operators test, the engineer's exam. But if you can see the back of it, there's a ladder collapse and proper positioning of ladders. And you'll hear me say like stuff when I'm talking about standpipe outlet scrub, and I talk about the code and why Ray McCormick's always talking 3 lengths and Dave McGrail's always talking 4 lengths. And Ray says you can do everything in the stairwell, which I believe is true, especially in the city of New York. They're exiting, like Lieutenant McCormick in the FDNY rarely on a standpipe job would need 4 lengths of hose. Dave McGrail and Eric Tullen and those guys, because they have a middle hallway outlet allowance, and their standpipe might be outside. They might have to go into the floor below and then come in, and then it's a sprinkler building where they've added a 50-foot travel distance allowance, and the outlet's not even in the stair.
Right.
They might need 5 or 6 lengths at times. And then you talk to Dave McGrail, and he's defaulted to always laying in a dirty hallway. He likes all the hose to be laid out the floor below. And then you talk to somebody from the FDNY, they're going to think that's absolutely crazy.
Right.
And both of them are correct.
Right.
It's based on the jurisdictional infrastructure that they've done their work in.
Which is the beautiful thing about when you come in and consult somebody, because that's what you analyze is their whole response model, resources, apparatus, staffing, everything, water supply, anyway.
It's all around water supply movement. We spent a lot of time with the surveyor's wheel, the water department, the lengths of the rigs. There's a lot of fire departments that have engines that are unnecessarily burdened with truck equipment. So I said on here, something you wanted me to talk about was spec and layout impacts fireground operations, initial unit actions, deployment model, scene management, and emergent situations such as maydays. All right, so let's say you're a fire department that has a decent amount of trucks. Like let's say you have a 3-in-1 ratio or something like that, 3 engines to 1 truck, but you have engines that are carrying combi tools and maybe some of them are quints. Maybe you have some dry trucks. And
the bulk of the American Fire Service is what you're talking about.
And then you're a fire department that starts looking out, and you go like, how can I increase my performance on fire grounds, right? And you go, well, let's do some riding positions. First engine does this, second engine does that. The guy that's sitting behind the officers, typically the nozzles, the other guy's the leadoff man or the door, and you start looking at trucks, you start doing riding positions, right? And Tony Carroll and I joint instruct sometimes, and Tony Carroll will be, wouldn't it be great if everybody had all the equipment they need when they showed up, and then it would just be their order they arrive in or what they need is what they pull. To me, that's like the absolute worst. Like okay. I couldn't think of a worse way. Like what I want is someone who's looking at this in a tactical and strategical sense. So I did a consulting job in a place called Tualatin Valley outside of Portland. And they're basically unwinding their quint model when I was there. I also did Clackamas across the way.
Okay.
And they had rule stations where you needed some enhanced engine companies. Like they needed set of jaws. Maybe they should have a 28-foot ladder instead of a 24 or 16-foot roof. Maybe they need a saw. But one of the things that was very difficult for them to understand is you want to start removing truck equipment from engines as you're unwinding your quint model and you're going to dry trucks. And incident commanders the battalion chiefs rank had a big problem with it. They're like, well, what if I need them to cut a hole, or what if I want them to?
Sure.
And I'm like, well, I go, have you ever showed up to an extrication and the first 2 engine has a combi tool on it, and you show up and Traffic control is basically ZIL. The rig's not in pump. There's no protection line down, and they got their combi tool out, and they're trying to pop the door. And the brand new dry truck company that has a full set of extrication equipment, that lays the mat down, that has a plan ever in place, is 3 minutes out. Why did they take the combi tool off the engine? Well, it's tactical discipline. They should have realized the truck's 3 minutes out. Our job's patient care, traffic control, calling PD, getting it set up, getting a protection line down, right? But the tool's there calling you. Hey, you can get to the patient better if you just pop the door. Everyone's going to do that. Like, it's very hard in an emergency not to do that. So spec and layout does dictate response, right? So what's the easiest correct there? If you've just unwound 5 quints and opened 5 dry truck companies and a rescue in your county, and you've made those dedicated trucks, and you used to have a bunch of engines with a lot of truck equipment on it, and you don't want them doing truck work anymore, what should you be doing?
Yeah, getting that equipment off there.
You should get that equipment off.
100%.
And as you get that equipment off, what can you do to the engine?
Oh, yeah, it starts to be task focused.
Shrink it down. You can lower the hose bed. You can get the bulk beds. You can get the Y evolution out, right?
Yeah.
So like, for example, like ladder operations on engines. You get a first due engine. This is very hotly debated in the fire service. When's it okay for the first due engine to go for a ladder rescue, right?
Right.
And I'm a big. I
like no known. I like no known as an indicator. But go ahead.
All right. So knowns on the first due engine. Typically, what length ladders do you have on an engine?
24 or 35, depending on how it's spec'd or et cetera.
All right.
If we're talking extensions, but yeah, you also got your roof ladders. But go ahead.
All right. So is a 35-foot ladder a one-person ladder?
Unless you were just a freaking beast, no.
Right. Probably not in an emergency. Should you go out and try to prove you can do it or whatever? I don't have any problems with that. But I'm going to say on a fire
it's not a one-person ladder. I'll give you 100%.
Right. So, but the NFPA, I would say the vast majority of engines in the United States have 24s and 14s on, because that's what's on the minimum standard.
Agreed.
All right, so let's just look at the average engine pulling up that has a 24 and a 14 on. Would you say that's fair?
That's fair.
All right, so a 24 and 14. All right, so 24 on a conventional foundation won't hit a third-story balcony, right? So a 14 on a conventional won't hit the second story, so you got to deal with the 24 if you don't have a 16, right? That's one of the reasons I like 16-foot ladders on engines, because if you mount the 16-foot ladder on the outside and you pull up and you want to put it into a second-story window, it has a greater chance of success, right? If it's not a slab foundation, right? So I do think about this stuff. Like, I really like 28s and 16s on engines, right? Because most people have legacy foundations somewhere in their first due. They're not all slabs, right? But you show up and there's a person presenting. Is a fall from a second-story window fatal?
No, I'm with you.
It's questionable, right? Like
I'm with you.
Most people are going to be like, oh, shit, they're not going to dive head first. They're going to hang down and try to drop or whatever. And I've seen that. I've had people jump upon arriving at fires, and typically they have a broken leg.
Right. It's survivable.
Like
it's survivable. Like, it's not enjoyable, but survivable.
It's right. So like most engines pulling up, when they go for the ladder rescue, the person at the window has the solution for them.
Just overcoming gravity. Is that what you're saying?
Well, it's not a non-fight. I would say most people will jump from a second-story window.
Sure. No, you're right.
Right. And most engines don't have ladders that will reach third, fourth, and fifth-story windows. Right. So you're doing something. You're doing an action where, in the end, them jumping's probably non-fatal. But remember, go back to that fire triangle that I was talking about. An engine company can deploy a hand line that will remove both heat and fuel faster than the ladder evolution. And by the way, if you do that, it most likely makes the ladder evolution possible.
Dude, I love it, man. Dude.
Right. So like if you deploy the hand line and you apply water over their head and you don't even go inside, it probably makes a relatively slow-paced, proper hand line ladder evolution possible. If you go inside and you apply water in a copious fashion and they're on the second floor and smoke's driving in the window, they're instantly going to feel relief
and they don't have
from
to
operations on the floor below. So like I think spec and layout dictates a lot of this stuff.
1,000%.
So like we had a big discussion about this. It's like, are there some agencies in America, do they even need ground ladders on their engines, right? If you had a 2-to-1 truck ratio and engine and truck usually tie on scene. Now, would I ever advocate for removing ground ladders from engines? No. But what I try to do when I'm consulting is I'll say like,
just challenge their thinking process.
Engines are fine with pre-connects, but they're not okay without a small line bulk bed. You can have one and not the other. The small line bulk bed can stretch short fast, medium fast, long fast. Right? It can do complex and uncomplex. It can do vertical challenging, vertical easy, well hole, non-well hole. It can do travel distance hard, technical. Like if you design it like they Palo Alto design it, where you can shoulder load all the hose, you can go around objects and stuff like that. Pre-connects are only good in their pre-connected length. That's why there's all sorts of solutions for lengthening pre-connects. Oh, I keep a bundle here for my pre-connect. And I found that in the city of Richmond. They have a 350 line. They're DC Beltway influenced.
Mm-hmm.
And then I started noticing on some engines, there's an extra roll of hose. And I go like, what's that here for? Well, in these certain projects, we really need it to be 400. So it's there. I go, well, why don't you just unconnect it and add that length of hose? And then if you need it, it's already on the line, right? So like, I honestly think if you're grabbing a bundle on an engine regularly and it's not related to standpipe operations, you have troubled spec and layout. The bundle, imagine this, like history-wise, there was no pre-connected hose. What invented the bundle? The standpipe or the pre-connected hose? Probably a little bit of both.
Okay.
Because once you've pre-connected a line and you've fallen short, how many times are you going to do that where you got to go back to the rig and then find hose until you go like, oh, wait a minute. When we fall short, we should have something ready to go.
Right.
So like, if you look at a department that's in all static beds, they don't recognize their bundle as something to extend a hose line with. It's just not in their mindset because they don't stretch short. Like, it doesn't happen. It will happen. I'm not saying they're perfect. Right.
That's not your point.
Next line, I tell people all the time, let's say you go do apartment fire and you have a fire that's on the second floor, right? Okay. And the 200 foot's mated and you're pulling the second line to Division 2. Why should you not pull the second 200 foot pre-connect?
Why should you not?
I'm going to say this building's 4 stories.
Go to fill me in.
The second line in a multiple dwelling fire shall be easily able to stretch at least one length longer than the first line.
Okay.
The reason why is, where does the second line often need to be in operation? The floor above.
Okay.
So if you're not a fire department that routinely fights fires in multiple family dwellings, you get in the habit of like, it's a 4-story apartment building. They got the first line on it. They're asking for a second. And then you pull a second line. You're up on the second floor and they go, oh shit, dude, it's apartment 312. We got some extension above. You're short. Bring me the bundle, right?
No.
It's been built into your culture.
1,000%.
So spec and layout. So back to how it dictates strategy and tactics. So one of the fire departments I consulted with Tualatin Valley, I started doing this rabbit hole thing with them. And eventually the hose and nozzle committee said, well, I don't understand why we have any pre-connects. Why don't we just have 2 inch and 3/4 bulk beds and a big bulk bed of 2.5, and that'll just be our attack package. And we're going to just have that. And I said, hey, that's fine. right? That's going to be a huge cultural change. I don't know if you guys can do it as a 25 station fire department. Like the rural firefighters are like, what? Why are we getting rid of pre-connects?
Right.
But I told the battalion chiefs, how often do you show up and you have 3, 4, or 5 lines deployed off one engine? And a couple of them said, yeah, it happens all the time. We hate it. Like everything's off one engine. It's stripped. People are tripping over each other. They're making stuff up as they go. I said, well, if you go to this, you'll never have that problem again. You'll always have the third line, if you need it, will be from where? Not the first 2 engine. Right. It's not present. So it took about 5 years, right? And there was a lot of heartache. But now when I talk to that agency, they go like, oh, yeah, we always have a second water supply. If we need a third line, it's always off a redundant engine. Why? Because it's just not possible to screw it up. They can only deploy 2 3/4 off the rig. That's it. So Chicago is a perfect example of this back in the day. They used to do 750 pumps and only had 2.5-inch hose. 3 beds of 2.5. 1, 2, 3. That's a 750 flow, right?
Right.
So it was all set up. 1 line, 2 line. That's it. Master streams were 750, right? Then ultimately they said, hey, small line's important. We're going to do some changes, right? But ultimately we want to keep things as simple as possible. And if you take pre-connects away from a fire department, well, how many evolutions do you need to teach when you're deploying a hand line?
Well, it's more than if you just have pre-connects. So,
well, if you have a pre-connect, if this is when we pull the 150, Dennis. This is when, if it's 3 stories and under, we can get away with the 300, but make sure, because sometimes we overstretch that. This is the 200, right?
Oh,
if you
yeah.
go to one mindset,
yeah,
one methodology, right? So to me, if I go to a place and there's, let's say, 5 handline evolutions and there's 5 supply evolutions, and I teach them something they want to add, I highly advocate not making it worse. I go, well, if you want to add what I taught you, remove one of these others.
Right.
Like you already got 10 plays here, right? So that's why Aaron Fields gets into all that, like rules of 3, and the Marines are like that. And I personally, Bruce Lee was somebody I thought was pretty at the top of his profession. And he always said, like, there was a famous quote, I fear the man that's practiced one kick 10,000 times, basically more than I fear anyone that's practiced one thing. 10,000 things one time, right? So it's like, ultimately you look at the agency you're in and then you figure out how Swiss Army knife you need to be. But I think engine companies should be like a buck knife on the attack side. Just, if you're going to skin a deer, use a buck knife. And like, we're looking at suppressing fire. How can we boil it down to just, these are the things we need?
Right.
I don't know. I don't think I did a good job explaining that.
I think you did. I really do think you did. I think it's just a complex. Here's the thing: is when you quiz me, I feel like I'm taking a test and I don't want to fail. And I'm like,
it's not like that at all.
Like a deer.
I like you. It gets people to think. So that emergent situation, right?
Okay.
That emergent situation. If you have somebody yell that they are out of water on the fire ground, right? You have somebody come up on the radio. They have a loss of water in their hand line. Would you rather be operating the rig that only can have 2 lines off it or the rig with 5 lines off it?
No, definitely 2 lines definitely seems like a better situation there. I mean, that's a pretty simple math.
Right. So it's just like, if you're a chief and you have somebody go down and they were doing a truck operation, hey, somebody's gone down and they're on the roof, right? Would you want to be managing a quint department or a dedicated truck department?
Ah, dude, you're preaching to the choir, because I firmly believe in dedicated, disciplines.
So if it's a dedicated truck, you know what unit they're from.
Yeah.
There's no mixing on the fire ground.
Yeah.
It's like, a member of Engine 2's down. What's Engine 2 do what's the second due engine? Engine 3 was the second due engine. What's the second due unit do on these types of fires? We know where to look for them.
Right.
You know what I mean? Everybody wants, we should be able to show up and do everything, right? And the Honolulu Fire Department had really that mindset, right? And then they had the Marco Polo fire, and I think it caused some issues. It was like, where are people? What are they doing? And they're very resistant to doing dedicated riding positions. And I told them when I was there teaching at their drill tower, I said, some of the confusion at that fire came because you don't have dedicated riding positions that are very spelled out.
Everybody starts on the same page so that you can audible from those pages.
Yep, and that's the spec and layout's the same way.
Right.
Like, you know, if you make it very simple, right, there's no confusion. If you pull up and you're a fire engine for long stretches over 200 feet, you have a bulk bed.
Okay.
And that's the one evolution everybody's trade on. No one's going to extend the blitz line. No one's going to join the two pre-connects together. No one's going to grab the bundle and try to do X, Y, Z.
Right.
It's just like, hey, the 200's not going to make it. We go to solution B, and this is the only solution. If you don't have a bulk bed, you don't have that. You have a bunch of evolutions.
Right.
This is how we join pre-attach together. This is how we extend them. This is how we extend the blitz line, you know. So, again, I think people don't look at it quite right. You know, that they think options make the box solid and options make the box weaker. You want the minimum amount of solutions that address the vast majority of problems.
I love it. One more question. Go ahead.
You want the problem in your box. You don't want to be thinking outside the box.
Someone said we got to be inserting constants.
That's me.
Yeah, that's me.
I said that. Anytime you see a variable and you can insert a constant, you should be inserting a constant.
I love that, man. That's one of my favorite quotes. I use it in my presentation, man. Greg,
I'm happy to keep going, but we're
at 2 hours. We're at 2 hours.
Yeah,
so you tell me. I got 5 questions for firefighters.
Okay.
So let's just do that. I had one. Which I'm pulling them up. I want you to be field honor, Dennis. Okay, I'll get you out of here. I know it's late over there.
It's okay.
In California.
I don't want to run over the all-time record. What's the all-time record?
It has to be Ike. Ike has to have it. I think he's close to 3 hours. So you got a long
safe.
buffer. Yes.
Yeah, I'm safe.
This is the final time that the original 119 episodes, 5 questions for firefighters. This is the last time the original 5 questions for firefighters will be asked. So hope you feel very honored. Here we go. Number 1. And here's the deal. There are no correct answers. It's 100% your opinions. I pass out the points. It's 100% my opinion on how good you did on the answer. So,
all right.
5 questions for firefighters. Number 1. What is the number 1 issue facing the modern fire service?
How effective water is, because it leads to people that don't know how to do their job properly. We get it. It's too easy. So that way, since water is so effective, even poorly done water will extinguish a fire. So people think they're being successful. So you're not capturing how much you suck, right? So that's the main problem. Like if water was 50% less effective, you would get 4 times the quality of firefighter. They would have the nozzle open. They'd be mapping their advanced. They'd have a lot more knowledge about how to apply water on the fire ground. But I can't do that. I can't put my thumb on it. It would be too cruel for the life side of the equation.
No, 100%. I like it.
So I really think that's the big problem. Understanding how water is applied and the way to do it properly is the number 1 problem.
I love that. So if I can encapsulate it, it's if the modern American fire service understood how much they actually suck and how good water is.
Yeah, it's like throwing a grenade into a room when you're trying to kill somebody. You're probably going to be successful.
Okay. Yeah. Okay. Yeah. I love it. No, 100%. I love the answer. And I will say this is the most original answer I think I've ever gotten on that question. I've never heard that before. And so I will give you max points on question number 1. So here we go. Number 2. What is the thing you are most excited about for the future of firefighting?
I think that one of the things that the fire service is a social place, and I think we were the early adopters of social media. And I think we had a lot of good uptake at the beginning. Honestly, I think if I wasn't hurt and retired in 2009, if I was hurt, if I had the same amount of time on job, and I was hurt in 1999, no one would even know who I was. I just hit it right, and it wasn't as toxic at the beginning. So I hit it just right. So I think personally, I'm an optimist around this subject. I think we've gone through toxicity here a little bit on social media, but what has occurred is the networking has come around and people are more result driven now. They're like, well, I don't care what department you're in, do you have value to the fire service? And I think the equipment manufacturers are getting in on the game and providing training like Elkhart and stuff like that. So I think there's a vetted by market forces and also other things that are going to lead to increased equipment design, increase in shared relevant material, and that the bullshit's going to be washed out even more.
I love it.
Over time. And I'd say an example of that, if I had to say like one thing that I'm very excited about, and I had a hand in it, but I'm not the only one. We could go on a history of why it occurred, but I think the large handline attack package of the future of the American Fire Service, if your target flow is between 250 and 265, it's going to be 2.25, 2.3 inch hose, and it's going to be a dedicated. You're not going to be trying to use something that's also a supply line,
right,
as a hand line.
Yes.
It's going to be a dedicated large
attack line,
large attack package.
No.
Yeah.
And we didn't even get to that in the questions because and it's beautiful what you've done in addressing the true diameter and the 2.25, which is what we carry. I got green True ID 2.25 on all our rigs, and I
didn't even know that. Like they told me they can't even make it fast enough anymore. Like it's just going. There's a few things I want to change on it. There's some coupling stuff.
The coupling stuff I wanted. I was gonna even bring it up, but that's okay.
What I think can be done with that is that where the lugs are on the coupling, I think we can do a ring that's full height of the lug all the way around.
Right.
So when you tip it forward, it'll actually have that same approach angle that was in the old 2.5 inch coupling.
So it won't hit the threads.
So it won't hit. It would be very simple to do. I've actually told the key about it. Unfortunately, they're like a lot of companies. They got irons all over.
Sure. No doubt about it.
Especially like with COVID and stuff. I don't actually make any money from the sales of any of that stuff. I just did it because I wanted it for clients.
No, and I don't think people understand the impact you've had on, not only that but nozzle size. Here's a weird one. It's a 13/16.
Yeah, and it's not just me. Other people are like, this is basically 150 at 60. I kind of wanted to see if it would work on 1.5 inch hose. And the pendulum's gonna swing too far one direction.
Sure.
We're gonna be down to I have a 27/32 tip that didn't work worth a shit on an 1.5 inch hose. So there's a whole waste bin of failed Dennis ideas, out in the backyard. So
fair enough. You talked to DC about all the 1.5 inch stuff and all that kind of thing, and
I made the 27/32 for DC because I wanted to see if 150 at 50. There's just so little surface area in that bottom 36 inches of 1.5 inch. I think Kentland runs a 150 at 75 on theirs, but it's still a very wild line. And here's the real rub with that. As the hose size gets smaller, the amount of water, so in the last 72 inches of 1 3/4 versus 1.88, it's 6.2 versus 7.2 water system weight. So it's about an extra pound of water. But when you're talking about most 1.5 inch is 1 5/8, and now you have True ID 1 3/4. There was a time when it was easier for me to get people an 1 3/4 by buying 1.5 inch hose.
Gotcha.
There was 1.5 inch hose that was closer to 1 3/4 than 1 3/4 hose.
Right.
So, but in the smaller hose sizes, especially the difference between a True ID 1 3/4 or a Sniper or something Mercedes is making, whatever, an 1.5 inch, the weight difference is very small, but the hydraulic dynamics of losing those 10, 20 square inches of surface in the last 30 is enormous.
Right.
I don't think it's worth it. It's just me out in the backyard experimenting, to see. And by the way, like, it's LeGear Engineering. I'm doing business as LeGear Engineering. I don't have an engineering degree. I have an engineering mindset. I've taken some engineering classes, but like I'm not, like, I need to talk to people like Steve Kerber. I need to talk to people like Dan Madrikowski. I need to talk to the people at the hose companies. I feel like if I had to relate it to a popular movie, and I hate to use this one, but it's the only one that came to mind, is like whatever Tom Cruise's character in the stock car movie, Cold Trickle.
Right.
I knew what I wanted, but I didn't know how to do it. I needed to sit down with somebody that ran the loom. I want stiffer hose. I want it to pack like this, and it was a lot of collaboration.
Right on, man.
There's 13 failures on True ID 1 3/4.
Really?
Yeah. There's 13 pieces of shit.
Well, that's as honest as you can be about it. All right, we're completely down rabbit holes. Number 3.
Yeah.
Best rank.
Wait, my points.
No. If you didn't get max points, you didn't get max points. So number 3 is
right.
The best rank or position to be in the fire service.
It took me a long time to like company officer as a lieutenant, and then when I made captain in Oakland, captain is in a single house. And if you have 2 good lieutenants in 2 different crews, you basically can kind of set the tempo for the entire firehouse. And then if you have a couple good chiefs and they realize that the captain of that firehouse is really in charge of the day-to-day problems and stuff, and you talk to your lieutenants and you say, hey, if it's an emergent thing, deal with it with your battalion chief that shift, but like house problems, everything, I want to come through me. If you can create that culture, like that, captain of a single house with 2 lieutenants is probably the most rewarding position where you can really dial. And it took me a while to figure that out, and I didn't get to do enough time in that position. So, I look back at my days of driving. That's where I felt most confident.
Right.
Believe it or not, I slept best as a member of a ladder company that's in the bird dog or irons position. Actually, I was pretty comfortable tillering too. Like, those were the best nights of sleep. So I kind of feel like when you look at your career, everyone's going to have different answers to this. And
sure.
And when you look at a Scott air pack and someone goes like, oh, the wireframe was the best, and this regulator by this company, everybody would make their own Franken SCBA. Like, this face piece fits me the best. This harness fits the best on my back. So, that's going to be a question that's hard to answer. But I really thought the captain, where you're truly in charge of the other 2 shifts. And the thing that sealed the deal for me was Mike Lombardo talking about that. And he said the same thing. And he said the best one was captain of an engine house with a single chief present. And he said, because the chief's your guest.
Oh, yeah.
Yeah.
Yeah. I like it.
Yeah. And I was like, oh, wow, that was pretty. He has a great story. If anyone ever runs into him, ask him his favorite position of fire service. It was a captain with the chief in the house, and I ran away from those stations. I wanted to be a captain of a single house on the edge of my battalion. Right on. So the other battalion chief, I was closer to the battalion chief that wasn't in charge of me than the battalion chief that I was. But anyway, captain of a single house with lieutenants.
I love it, man. I love that. 100%. And this is the cool thing about the 5 questions for firefighters, and something that was completely accidental. There is no correct answer.
Oh, I know.
It is strictly.
But it is captain of a single house with 2 lieutenants.
Dude, that's very specific. I don't know how many people can yeah. No, I love it. Where am I at? Pulling up my notes. Best advice you have ever received.
Best advice I ever received. Let me think about that. I'll answer the 5th one. Come back to that.
Okay. Number 5. Coming at you. Heavy fire. Searchable space. Would you rather be assigned to the nozzle or first in on VES?
Nozzles. You can make a larger impact. You can make the VES possible. Like, you can make a larger impact. That's like, Do you want to be the wide receiver that's being thrown the touchdown pass, or do you want to be one of the members that might block on the football field? It's like you want to be the guy receiving the ball. Like,
I love it, dude. No, I can't. And because of the analogy, that's max points on that one because the analogy is beautiful for how it plays out, and that's what I'm looking for. So I still got to throw it to you because you haven't answered number 4.
Best advice.
We'll wrap this up as soon as you answer number 4.
Yeah. So best advice. I told you I got some, disappointing news today about something that I thought was going to occur maybe a few years from now, but it's going to have to be delayed.
Right. No specifics, but yeah, you did mention it.
And it was something I had a hard date in my mind, like I was like, and I was like, it's definitely not going to be what I thought it was. It's not the end of the world, but I think my wife, and I'm horrible at this, but you should only really worry about things that you have some reasonable ability to change. Like, I'm like, I think the fire service is full of people that can make really good changes in their company at their company level. And they're freaked out because like the policy's bad or whatever's bad. My wife told me today, like when this thing happened, she's like, well, there's nothing you can do about that. It's like, it's either going to be a problem or it's not going to be a problem. And she's right. Like this particular thing, it's just like, basically it's tied to bureaucracy.
Right.
And there's nothing, it's like, I'm just in the tool. So I would say probably, and I've heard different versions of this from multiple people to like focus on the stuff that you can change or when there's a huge problem and there's nothing you can do about it, try to put it out of your head or whatever. Right. And I would say that's probably easier said than done, but probably universally a good thing.
Beautiful. And one of my favorite pieces of advice, so of course you get max points on this one because circle of influence, circle of concern, Stephen Covey, when he talks about it, he talks about this is what you can affect. This is all the shit that you worry about,
So yeah, I've never heard any of that stuff.
No, but, it's beautiful, dude. But like you said, it's been said 1,000 times, 1,000 ways, and your wife encapsulated it, and you just encapsulated it beautifully. And so there it is. The 5 questions for firefighters, according to fire engineer, hydraulic engineer, water wizard, Dennis LeGear.
The nozzles is definitely the correct answer on that last one.
No, that's what I judge it on is how much passion is behind the answer.
Yeah.
So officially 119 scraps are in the books. The last time the original 5 questions for here's the deal, guys. I don't even know what I got Ray McCormick coming on in a few days. It's like on Saturday, New Year's Day, first episode of 2022. And I have to have 5 new questions to ask him. I've had a whole bunch given to me by people and viewers and et cetera. I have no idea what the next 5 questions are going to be. I just want them to be as good as the first 5. So anyway, we'll see how that goes. If someone wants to get a hold of you, if they want to bring you in to consult, et cetera, or just reach out to you and ask a question. A lot of people had questions I didn't get to. Guys, I apologize. Before I let you answer, Dennis, I'm going to tell everybody this. I'm working on a way to be the audience gets to interact better with the scrap. And I'm going to try and unveil it with Ray-Mac here this week, but I don't know if it'll happen. So anyway, back to Dennis. How to get a hold of you?
Email, Dennis at hydrantsnozzles.com is the best way. And I'm the only Dennis LeGear listed in the United States, so it's very easy to find my proper email address. The website's not changing because someone built it for me and I have no idea how to do it, and it was given as a gift. So I've heard people go like, update it, blah, blah, blah. The email's on there. Email's best. And I try to keep to less than 2 things a month. So like, I'm pretty task saturated, time compressed. So if there is any interest, and you're thinking budget cycle or whatever, try to get a hold of me early. Like I'm looking into 2022 spring. Sometimes I can fit people in. Don't not call, but it can be. Ask Corley, how hard was it to get a hold of me?
Dude, the guy is in demand. That's all I can say. There is a high demand and a low supply, so you figure it out. That's what it comes down to, man. So yeah. I don't know if I can make it any plainer than that.
Thank you. And a lot of it's because I'm goofing off too. Don't feel too sorry for me. I have a good time goofing off.
That's the best part, man. He better be. So, honestly, you should be. FirehouseVigilance.com. Holidays are over. If you're like me, everybody spent too much on over the holidays. So if you want to go get some swag, do so. I always like to hype the website and the Mutts Don't Scrap and the hats and etc. But next up, New Year's Day. I'm pretty excited. It was hard. I don't know. I honestly want to say this because Dennis LeGear was the hardest guy to get on the scrap out of 119 scraps. But I made it happen. And then the second hardest guy is Ray McCormick, who is coming up in a few days. And so he's number 120 on New Year's Day. There's lots of football games going on and everything like that, but we're going to have a scrap on Saturday, New Year's Day. And he is going to be the first one to answer the brand new 5 questions for firefighters. He doesn't know what they are. I don't know what they are. It'll be fun for everybody. Next place I'm heading is CF Tactics Fire School in February down there in Pensacola. I'm excited. If you are going to be there, please look me up. I love to get pictures with everybody. I love to post those pictures and put hashtag Mutts Don't Scrap. If you, all my housekeeping right here at the end. If you think the scrap brings value to the fire service, please go to firehousevigilance.com. Please support it in any way, shape, or form. I'm working on some way to I don't know. I'll work on it. I'll tell you what I'm working on later. Final things. I got to show off these because Ray Dorval sent me this one. Man, I don't know if I can get it to, if the lights will let it focus. There it is. Way of the nozzle. Make the push. Beautiful, man. There's the smoke coming out of the skull. Yeah. Miami fire. Miami-Dade County, nice. Florida fire. Yes. That's from Dorval. The black. Big black. Sending that to me. Ortega. This one came in. Firehouse 3. Same place. Miami-Dade. These guys are awesome, man. I love them. I wanted to send it out and say thank you guys. They're going in the flag back there with all the rest of them. I appreciate you guys so much, so I wanted to shout it out. That's it. Dennis LeGear, brother, you actually crushed it. 2 hours, 21 minutes is what I show. So you definitely made an impact.
Yeah, well, that's what I figured we didn't get to everything, that's for sure.
Dude.
That's a nice thing about the fire service. Like, if you're passionate, you can just keep going.
Here's the deal. I hope you will come back because there's stuff I really want to touch on 2.25 versus, just to be in the big attack line. I want to touch on hose spec and specifically 40, 60 PSI nozzle range and the misconception of how come I slap a smoothbore on and my hose doesn't work? You know what I'm saying?
I have a little chart here I haven't shown anybody that I was going to try to share tonight.
Man. I love exclusives.
Yeah, it was a nozzle bite hydraulic force at work is the title. This one's a little. This one actually, it took me understanding that as velocity goes up, sidewall pressure goes down.
Right.
And at the Elkhart, I was very privileged. There was a European and foreign contingent that went to the HROC this year, and Elkhart did like a Europe meets U.S. dinner, and I was actually sit next. I think they kind of did it like a wedding, like they sat me next to an actual like hydraulic engineer, and I was like, how can I explain that as velocity goes up, friction loss is not the enemy, and as velocity goes up, hose actually becomes less stiff, and he's the one that gave me the thing that I used earlier in the scrap, where I said, if you take it to infinity, if you take supply hose and you keep flowing more and more water to it, at a certain velocity, it'll want to just collapse in on itself, right? There's nothing left on the sidewall.
You're like some Einstein. Now you're getting into Einstein stuff, and it's like, no, and like I'm trying to put it into words. As the velocity increases, as you increase the velocity, kinks happen more often? Is that a good way to say it or no?
Well, hose is just going to be more squirrely and wild. Anyone who's used a Vindicator nozzle on 1 3/4 and gone to 300 gallons a minute and try to put a kink in it, they'll see how quick it flows out. But then if you try to like hold the hose far out, you get a really wild situation. So Aaron says balance. He's using the word balance. He's correct. knowing all the little ingredients it's causing it to behave correctly. Like a lot of us know the recipe, like half the diameter of the diameter, this thing. We need a stiff hose, but actually quantifying like what's occurring. I'm sure if I was if I had a physics engineering degree or something from Berkeley, I'd be like, oh, this is like obvious what's occurring. But the picture over the last 2 years, the picture's become way more clear. And that's one of the reasons that combat sniper got developed, to get it to fold a little better, but also behave more like True ID. There's some gimmickry that is pretty interesting that is proprietary to Key on that stuff. But they all have it. There's all kind of ways. But I know when you get to a certain spot, when you shoot for excellent, like the True ID 2 1/4, I'll say this right now, and I think it's market forces and more competition's better. Nothing touches True ID 2 1/4 now. It's the heaviest out there, but there's a reason it's heavy. There's a reason it's weighs it as much as it does coupled per 50. And I think you've used it, right?
Oh, yeah.
It's pretty.
It's our high-rise bundle. I mean, 100%. Yeah. It's not. It's our high-rise.
Should be off your engine too, but you'll get there.
We have quints only. We don't have dedicated trucks.
Oh, you don't have that space.
It's off everything. Yeah. So.
Yeah, that's
100%, brother. Thank you.
Right.
Thank you for giving me.
Later.
Real quick, my wife has corrected me and said my next stop is not in Florida. It's in Nebraska, February 4 through 6. I'm teaching the 9 L's of leadership. So thank you. I'm sorry. I wanted to correct that. Other than that, Dennis, thank you. Everybody listening, thank you for the questions. I hope the tone stays silent unless it's burning. Everybody stay safe out there.
Good night.